Good evening, everyone. Welcome to Byju's Exam Prep IAS. First, before we begin, a quick audio and video check if everything is fine. All right, wonderful. So, today we are going to start with some of the chapters which are smaller chapters yet important chapters. Although these chapters that we are discussing, these are not mentioned in your UPSC syllabus as such, but these are areas from where we expect questions to come. These are areas from where we can expect that something or the other could be asked. So first we'll start with vaccines. We'll discuss certain aspects of what vaccines are, and then we'll discuss about defense. So these are two chapters that we are going to begin with. Both of these are small chapters. And then after that, we are going to move to a big chapter, that is IT and communication, a chapter which is going to be very, very important, especially in your prelims examination. So this is what we are going to do in this regard. So first, to start with, we are discussing the chapter on vaccines. Now, when we have vaccines here, understand something, that what is the basic difference between a vaccine and a medicine. This is something that should be very clear in your mind, that what do we mean by vaccine and what do we mean by medicines. So let me ask you this. What do you think is the difference? How is a vaccine different from a medicine? Can you tell me? Some of which differentiate between vaccines and medicines, but what exactly is the difference? So yeah, Priyadarshini, you are correct. Devyani, you are correct. Anil, you are correct. Shreya, more or less, you are correct. Hmm. So basic difference, understand the basic difference. A lot of points that many of you have said are correct points, but that's not the very important difference. The difference is that medicines are supposed to cure and vaccines are supposed to prevent. All right, so that's the basic difference, that medicines are supposed to cure and vaccines are supposed to prevent, meaning that medicines will be taken when somebody has already fallen ill, when you are already diseased. This is when you will take a medicine. Vaccine has to be taken as a preventive measure. That is, you have to take a vaccine before the onset of the disease, not after. So for example, somebody suffering from a certain disease takes a vaccine. It's not that vaccine will start working on it. No, vaccine is supposed to be taken as a preventive measure, whereas medicines you take when you already are ill, when you already have fallen ill to a particular disease. That's the basic difference. So other things also that some of you have written, they are okay in terms of differentiations, but this is the real difference between what is a medicine versus what is a vaccine. So that's why medicine is curative, whereas vaccines are preventive in nature. That's the basic difference. Now, how do we define a vaccine? The meaning of a vaccine: suspension of a weakened, killed, or fragmented microorganisms or toxins or of antibodies or lymphocytes that is administered primarily to prevent a disease. Primarily to prevent a disease. That's the basic difference. That's the most important difference between a vaccine and a medicine. Because when it comes to a vaccine, understand this, that when it comes to a vaccine is supposed to prevent a disease. And as many of you had written, that vaccines would have mainly the virus in weakened form. That is correct, but that also partially. Not every vaccine has a virus. There will be certain vaccines that will have viruses, but there are others which will not have a virus. They can be made of chemicals, they can be made of genetic material, and so on. So it's not always important that it's made of a virus, although in most of the cases we see that that's the easiest way to make a vaccine, when you do it on the basis of, or with the help of a virus. So that's why it can be any weakened, killed, or fragmented microorganisms or toxins or antibodies or lymphocytes administered primarily to prevent a disease. Now, when it comes to the working of a vaccine, let's try to understand how does a vaccine work. So what we see is that vaccines generally would mimic a disease agent and try to stimulate the immune response, and many a times they are also called as pathogen imposter. Imposter meaning that they are trying to uh, do the exact same things, or they are trying to behave like a pathogen. They are trying to act like a pathogen. They are imposing. They are impose. They are imposing the role of a pathogen. That's why they are called as pathogen imposters. Now, overall, just understand how exactly a vaccine works. The entire mechanism of working of a vaccine. As soon as a vaccine is delivered, delivering a vaccine, when we deliver the vaccine, what we are delivering is something called as antigens. Something called as antigens. So antigens will be delivered. Now, what do we mean by antigens? Antigens basically are anything against which our immune system will respond. Anything against which our immune system responds is called as an antigen. So antigen means this. So antigen basically is anything against which our immune system our immune system responds. Anything against which our immune system responds is called as an antigen. Now, as soon as these antigens are delivered, these antigens could be anything. They can be made of certain chemicals, they can be made of something which is toxic for our body, they can be made of a virus, they can be made of a bacteria, they can be made of genetic material, they can be made of anything. All right. So, anything against which our immune system would respond or would try to fight against. Now, as soon as these are delivered to the body, they come across something called as antigen presenting cells. All right, they would come across antigen presenting cells, and these antigen presenting cells, they basically have a simple role, and their role is that they are the ones which will first try to make sure that the antigens stick to their body. All right, they will make sure that antigens stick to their body, and then they would go to the T cells, the T helper cells. So it's like you can think of them like night watchmen, or maybe the patrolling police at night, that they would just roam around with their jeeps to catch any criminal. That if there is something that they find which is unwanted, then they would catch the criminal. So the role that a patrolling police van would have at night, or a night watchman would have, something similar is the role of antigen presenting cells. Antigen presenting cells will keep roaming around the entire body in the bloodstream. All right, in the bloodstream they'll just keep roaming around in the body, and whenever they come across anything that is unwanted for the body, anything that they can't recognize, anything that they see is threatening, then in that case they would make sure that they catch hold of it, meaning that they'll make the antigens to stick on the body, on their surface. So this is the role of antigen presenting cells. So next is antigen presenting cells. So antigens stick to stick to the body of antigen presenting cells. These antigens would be taken to the T helper cells. These antigens will be taken to the T helper cells. So that is the role of antigen presenting cells, that these are, you can say, like these are like the patrolling. I'm just writing it here so that you remember the reference. They are like the patrolling police van. Now they are being taken to the T helper cells. T helper cells, you can say that this is like the police station. that now they have been taken to the police station. So now T helper cells. Now T helper cells will try to understand what kind of antigen it is, and accordingly they would ask the B cells to come in. All right. So now what the B cells would do is they would try to analyze what this antigen is. They would try to analyze what this antigen is, and based on what they understand, they would make something called as antibodies. So plasma B cells, they basically will make antibodies based on their understanding of the structure of this antigen. They will try to figure out how to attack. They'll try to figure out how to attack these antigens, and as soon as they figure out how to do that, they'll make antibodies accordingly. And that's why many a times they are called like locksmiths. That these are like locksmiths, that they have a lock in front of them where they do not know the key. They don't have the key, so they have to figure out what kind of lock it is, and accordingly they have to make a key. So these antibodies are like the keys to these locks, that is the antigens. So antibodies will be made. So antibodies, basically these are proteins produced by plasma B cells to destroy antigens. All right, to destroy antigens. So this is the role of antibodies. Now what these antibodies would do is that antibodies will simply go and stick to, I mean, they would just lock onto the body of the antigens. So that's why I'm saying that these are like keys, that all these locks, they are just fitting into these locks. So now in a manner they would simply go and mark the antigens. They'll just go and mark the antigens by locking on the surface, because plasma B cells will produce lakhs of these antibodies. Thousands to lakhs, you can say, of antibodies will be produced by these plasma B cells. Now, once that has happened, once this has been done, this is where we see that the role of killer T cells start. Now, killer T cells, these are like assassins. These are like assassins, meaning that they would just try to they would just find their mark and they'll kill them. So their mark right now is what? Everything that has been marked by the antibodies. So antibodies, as you can see, that antibodies have marked this antigen, and killer T cells will just go and attack. Killer T cells will just go and attack these antigens. So killer cells have no other job just to just understand what has been marked by antibodies, and whatever has been marked by antibodies, they'll just go and destroy them. That's the role that they play. All right, that's the role that they play. So overall, this is exactly what they would do. So now, overall, what has happened in this entire process is that the antigens have been destroyed, meaning that the vaccine that was delivered to the body, that vaccine has been destroyed. Now if the vaccine has just been destroyed, how does it help? How does it help in preventing the disease? The answer lies in memory cells. So memory cells, basically, if you see these are called as memory cells, and all these memory cells, they basically now remember. These are cells that remember what was done, what was the mechanism that was followed, what was done to destroy these antigens. They remember that. In a manner, you can say that while this entire procedure was happening, a video recording was happening, and the recordings are available later for the revision, right? Just as how you have the recordings, similarly they would also have the recordings later, so that they don't have to go through the entire process again, and bits and pieces they can revise very quickly whenever next time a situation arises. So when the next time situation arises, these memory cells, they will start playing a very, very important role. So now, when the actual pathogen enters, when the actual pathogen enters the body, the entire same process will be repeated. The entire same process will be repeated. First, antigen presenting cells come, they would make the antigen stick to their bodies, then they will carry them to the memory helper T cells this time. All right, they will carry them to the memory cells, and memory T helper cells will quickly realize that this is exactly the same or somewhat the same pathogen as what we had encountered earlier. It is very similar in its structure to the antigen that we have already fought once. And that is why we say that the vaccines, they try to mimic. They try to mimic the antigens, they try to mimic the actual disease or the actual pathogen. That's why many a times when the vaccines are made of maybe the same virus or maybe a variation of the disease causing virus. That is why we use very similar viruses, either the same virus which has been killed and used, or maybe it has been weakened a lot and used, or maybe something that belongs to the same species but is not the exact same virus. For example, in COVID-19, we know that in case of COVID-19 also, some of the vaccines that have been made, these vaccines contain virus, they contain coronavirus, but the coronavirus that does not infect humans but infects chimpanzees, for example, right? So that's why they are very similar in structure, because they are coronavirus, but they are not SARS-CoV-2 virus. SARS-CoV-2 virus is the kind of coronavirus that causes COVID-19. But there are other coronaviruses also. There are different types of coronaviruses. Many of them are harmless completely. Many of them will just cause some kind of, you can say, cold or cough, etc. That's it, and nothing beyond that. So they'll be very mild, but they are very similar in structure. So they can be used to train the immune system, and this is exactly what we do. That when we inject the vaccine, we inject something which is similar in the structure and the shape, so that the entire immune system understands how to destroy that antigen. And when another similar antigen arrives later, then the same process will be repeated with the help of all the memory cells now, and these memory cells will be able to act faster this time. So in a manner, we build immunity. All right, so purpose of the vaccine, that's why the purpose of the vaccine is to build immunity against a pathogen. Build immunity against a pathogen. This is the purpose of any given vaccine. So this is what they do with this entire process. Now, to carry out this process, there are different types of vaccines. There are whole pathogen vaccines, subunit vaccines, and nucleic acid vaccines. So whole pathogen vaccines, basically, as the name suggests, this is where we are using the whole pathogen. The entire pathogen is being used, and that's why these are called as whole pathogen vaccines. So these whole pathogen vaccines, they basically are of two kinds. They are inactivated vaccines and live attenuated vaccines. Inactivated vaccines and live attenuated vaccines. So inactivated vaccines are the ones where you already kill the germ, you kill the pathogen, or you kill the microorganism before being injected. So that's why we use killed version of the pathogen. And in case of live attenuated vaccine, you use the weakened form of the pathogen. So that's the basic difference between inactivated vaccine versus live attenuated vaccines. So this is how these two are different. Understand this. So whole pathogen vaccine. That's why this is whole pathogen vaccine, where we are saying that this is where killed or weakened version of the pathogen might be used. Now, overall, so this is the first kind of vaccine called as whole pathogen vaccine. Then we have the subunit vaccine. Now, subunit vaccine is where some part is used. We just, that's a subunit, because some part will be used. So it could be just a part of the vaccine, just the one part that can act as an antigen, only that part of the vaccine would be used, or some kind of toxin will be used, or some kind of genetic material will be used. So all these things are actually possible, and that's why only a part instead of using the entire pathogen. That's the basic difference. And then we have the nucleic acid vaccine. So nucleic acid vaccine simply means that this is where we are using the genetic material. We are using genetic material as vaccine, and that's what we call as nucleic acid vaccines. So we have mRNA vaccines, DNA plasmid vaccines, recombinant vector vaccines. All these can be called as nucleic acid vaccines, because in one way or the other, genetic material, whether DNA or RNA, any kind of genetic material would be used in all these cases. Now read this question. Although we have not discussed anything about the recombinant vector vaccine, but I just want you to use the knowledge of biotechnology in this question and tell me what the answer should be. And I'm telling you that you know the answer. If you had to take an intelligent guess to what the answer should be, take an intelligent guess and tell me what you think is the answer in this question. And let me discuss this with you. Wonderful. So 71% of you have given the correct answer. Let me discuss this with you. With reference to the recent developments regarding recombinant vector vaccines, consider the following statements. First is genetic engineering is applied in the development of these vaccines. Second is bacteria and virus are used as vectors. Now, look at the terms. First term is recombinant. Where did we learn about recombinant? Where did you come across this term recombinant? Give me the example. Where did we come across this term? Yeah, DNA. What exactly was the process in genetic engineering where we discussed the word recombinant? There's one particular method that we discussed where we discussed a technology. What was the name of the technology? Yes, Prem, recombinant DNA technology. So we had discussed recombinant DNA technology where we had discussed that we are joining two genes, one coming from the carrier, that was the virus or the bacteria, and one coming from the desired DNA. So we discussed the term recombinant there, and that is where we also discussed the term vector. What did we discuss about the term vector? That it is the carrier, correct? We discussed that it is the carrier of the gene, and carriers could be what did we discuss? We discussed that carriers could be either bacteria or virus. Now look at the question. Genetic engineering is applied in the development of these vaccines. If the term recombinant is being used, then yes, genetic engineering is being applied. Bacteria and viruses are used as vectors. Yes, they can be used as, both can be used as vectors because both are carriers of genes. So that's why the correct answer will be both 1 and 2. That's why I said that the knowledge required is not the knowledge of vaccines but rather the knowledge of biotechnology. So now, just to take certain examples that we came across during COVID-19, one is inactivated vaccine. Now, in case of inactivated vaccine, as I discussed, that this is where we use the killed version of the germ that causes the disease, and that is where we see that this is something that will help us in protecting against all these diseases. And in case of the COVID-19 vaccine that we used in India, the Covaxin virus, sorry, Covaxin vaccine that we used, this basically was an inactivated vaccine. Similarly, there are live attenuated vaccines where where we use weakened form of the germ, or in a manner you can say a dormant form of the germ that causes a disease. So in this particular scenario, again we see that there are all these cases where they can be utilized. So live attenuated vaccines, in case of what we use in India, Covishield. Covishield vaccine actually was a live, or is rather, a live attenuated vaccine. Similarly, there are mRNA vaccines. So mRNA vaccines is where we make the use of messenger RNA. Now, messenger RNA is a kind of RNA that carries messages or carries instructions for making proteins in our body. So they carry instructions, they carry messages for making proteins in our body, and that's where we see that messenger RNA, they become very very crucial. All right, they become very very important. And now what we do in this messenger RNA vaccine or mRNA vaccine is that instead of delivering a virus or a bacteria or a pathogen, we deliver mRNA. All right, we deliver mRNA. So when we deliver mRNA, delivering mRNA would means what? That now messenger protein enters the body, and after entering the body, they would start making antigens. All right, they'll start making antigens. So overall, so mRNA vaccines make proteins, or you can say antigens in order to trigger the immune response, and this is after they enter the body, after they enter our body. So that is where they are different. All right, that is where they are different, because mRNA, otherwise when it comes to mRNA, I mean all the other vaccines, we are directly delivering the viruses in other vaccines. But in this case, we are not delivering the virus, we are instead delivering mRNA. And this mRNA, once delivered in the body, this is what will start acting. So mRNA vaccine. So again, COVID-19, for the first time we have seen that widely we have used mRNA vaccines. And again, there are two important examples from other parts of the world. One, the Pfizer vaccine, the vaccine made by Pfizer that was used largely in the US, and then another vaccine made by Moderna that was used in largely in Europe. So these two vaccines actually are mRNA vaccines. Then there are recombinant vector vaccines. So as we just discussed, that this is where we are combining two viruses. That's why recombinant vector or recombinant or viral vector vaccine, because two different viruses are being combined together in making this vaccine. So against COVID-19 we have used it. And if you have heard of Sputnik V from Russia, the Sputnik V vaccine, this basically is recombinant vector vaccine or viral vector vaccine. Then apart from that, there is the DNA vaccine also. Now this DNA vaccine has been made by Zykov D. This is the Zykov D that has been made by Zydus Cadila. Now they are the ones who have made Zykov D, which is the world's first. It is the world's first plasmid DNA vaccine. Now the speciality about DNA vaccine is that first and foremost, it has been made in India. World's first DNA vaccine made in India. Secondly, a very important point here is that they use a mechanism called as pharmajet. Now, using pharmajet means that instead of delivering through injections, there are other mechanisms being used. For example, if you have heard, this was in the news, that now India has nasal vaccine. Heard of this nasal vaccine? Nasal vaccine meaning that through nose drops, the vaccine is being delivered in the body. Now, when it comes to the nasal vaccine, this becomes crucial because it helps in fighting something called as vaccine hesitancy. Vaccine hesitancy. So vaccine hesitancy, they are trying to fight vaccine hesitancy. So vaccine hesitancy is when somebody is hesitant in taking a vaccine. Somebody doesn't want to take a vaccine because of n number of reasons. And one of the most common reasons to why somebody does not want to take vaccine is the fear of needles, the fear of injection. And because of the fear of injection, people don't want to take vaccines. So nasal vaccine is an answer to those kind of fears, which is called as vaccine hesitancy. So overall, we see that there are all these cases of different vaccines. Now, when it comes to any vaccine, also understand what do we have in a vaccine. So of course, there is the antigen, and this is the most important component. That's the main component of any vaccine. But apart from that, there are other aspects of vaccines also. There are other constituents in a given vaccine. So understand what we have: preservatives. So preservatives basically prevent the vaccine from becoming contaminated. So that's why preservatives will be used. Then there are stabilizers. They help in it preventing the chemical reactions from occurring within the vaccine. Then there are surfactants, and these surfactants keep all the ingredients in the vaccine together. Then there are residuals. So residuals is where we have substances which during the manufacturing might have been used, but now they have no effect on the vaccine, neither positive nor negative. They have no effect. They are just the leftovers in the vaccine. So these are called as residuals. Then there are diluents. So diluents basically is where we use it to dilute a vaccine. All right. they are used to dilute a vaccine to correct concentration. So they could be something like water, that in which all the ingredients are going to be mixed. So that solvent will be called as the diluent. And then lastly we have the adjuvant. So adjuvant basically will try to create the immune response by keeping the vaccine at the injection site for a little longer, or by stimulating local immune response. Now understand what they do. What can possibly also happen is that, let's say vaccine has been delivered into the body through an injection. Now once the vaccine has been delivered, it may so happen that the antigen presenting cells do not detect it. So they do not find the vaccine, they do not find the antigen. So what happens then is that the antigen has been delivered to the body, and it gets excreted out of the body without being noticed by the immune system, without being noticed by the antigen presenting cells. Now if that happens, then what does it mean? It simply means that the vaccine is ineffective. This is where adjuvants become important, because adjuvants play a role in creating an immune response. They play a role in creating immune response, meaning that they would ensure that they create some response. Let's say, just as an example, that uh, it would be like that if, let's say, I wanted response from police. So then what I do, I go in front of a police station and try to steal the police car, or try to do something unwanted just at the door of a police station. So obviously police will notice, and maybe I'll get thrashed, or maybe I'll be locked up, but at least police will notice. This is exactly the role of an adjuvant, that once they enter the body, they would ensure that they somehow get the notice of the immune system. They make sure that the immune system notices that there is something, and once the immune system notices, then after that the entire process will just play out as we discussed. So that is basically what the role of an adjuvant is. So overall, that's why adjuvant becomes very crucial in stimulating the response of any given, or of the immune system. Now the next topic for us is efficacy of a vaccine. But before we understand what do we mean by efficacy of a vaccine, understand this term called as clinical trials. Before any vaccine enters the market, before any vaccine would enter the market, there are these stages of clinical trials that will be conducted. First, starting with lab studies, where we see that the studies on the vaccine will be conducted, where we'll try to understand each and every aspect of the vaccine, their chemical properties, physical properties, all that. Plus, maybe some tests will be conducted, like the tests on the tissues generated by stem cells. So we can do the testing on them. Then some animal testings happen. So all these kind of lab tests will be done. And once we are sure that this is safe and this is effective, this is when it will enter the clinical trials. And the phase 1 of clinical trials is where you have a small group of people on which the vaccine is being tested. Small group of people, maybe up to 50. 50 is not a fixed number, up to 50. So up to 50 people will be there, and on them these vaccines will be tested. If the testing is good, if every result is positive, it will be noticed and it will be uh, catered to properly. Once we are sure that there is no negative impact, we move to phase 2, where maybe there are up to 500 people. There are up to 500 people in phase 2. All right. Now in phase 2, there are up to 500 people. Testing has been done on them. Everything seems to be fine. Moves to the next stage, next phase, where we have up to maybe 5,000 people on which this study is being conducted. And if this is also good, if this is also safe and all fine, then it enters the last phase, where up to 50,000 participants could be there. Sometimes 20,000, 30,000, sometimes even 70,000 participants. So on an average, you can say that up to 50,000 participants, and we'll test it on them. So in this manner, clinical trials will be conducted in all these phases to ensure the safety and efficacy of a vaccine. And once we are sure, this is when it enters the market and then will be sold in the market. So in the last stage, in phase 4, we test something called as the efficacy of a vaccine. So understand what we mean by efficacy. This is a case study that was published by Pfizer. Now overall there were 43,000 participants. And out of these 43,000 participants who were given the vaccine, there were 170 people who got infected with COVID-19, even after being vaccinated. And this is how we calculate efficacy numbers. You might have come across these numbers in the news a lot of times during COVID-19, that Pfizer has an efficacy of 95% and Moderna has 94%, Sputnik has 92%, Covishield has just 67%. So all these numbers were being published about efficacy of a vaccine. So understand how efficacy is calculated. So out of these 43,000 people that we have, they will be distributed in two groups, 21,500 each. So you have two groups, 21,500 each. So now they have been divided into two groups. One group will be given vaccine, they will actually be vaccinated. The second group will remain unvaccinated, they will receive placebo. Placebo means that you have been told that you are getting a vaccine, but in reality, you are not. In reality, perhaps they have just delivered water through injection and nothing else. So that could happen. And that will be called as placebo. And you do not know. You have been told that you are being given the vaccine, but you do not know that instead of giving the vaccine, they have given you placebo. So suppose that out of these 170 people who got infected, 85 were from the vaccinated group and 85 were from the unvaccinated group. It would simply mean that the vaccine is not effective, because whether somebody got the vaccine or somebody got the placebo, everyone got infected. So it means that the vaccine is not effective. Let's say the second case, where none of the people who were vaccinated got infected and all the 170 people who got infected had actually received a placebo. That would mean that the efficacy rate is 100%, that everyone who got vaccinated did not get infected and everyone who was not vaccinated got infected. So then in that case, we'll say that the efficacy is 100%. This is how efficacy is calculated. The actual case in case of Pfizer was that there were 8 people from the vaccinated group and there were 162 people from the unvaccinated group. This is how the calculation is done on the basis of uh, who has been given the vaccine versus who hasn't been given the vaccine. So they would do the calculation in this manner, that you have 162 people, so you have 162 and there were 170 people in total into 100. So that comes out to be somewhere around 95.3%, if I'm not wrong. So it comes out to be 95.3% approximately. So that is why we say that efficacy of Pfizer is 95%. This is how the calculation is done. So this is how we will calculate the efficacy of a vaccine. So if you look at the efficacy numbers, these were the numbers that were published by various companies. 95% by Pfizer, 94% Moderna, 92% Sputnik, 89% Novavax, 67% AstraZeneca. This AstraZeneca basically is the Covishield in India. This is the Covishield in India, and then Johnson and Johnson showing 66% efficacy. Now, overall, many a times these efficacy numbers, they actually may not portray the real scenario, because efficacy is about whether you got infected or you did not get infected. Correct? So whether you got infected or not after getting vaccinated. So this is basically the calculation of whether a person got infected even after being vaccinated. All right. So even after being vaccinated, did they get infected or not? So, but when we look at the aspects of what a vaccine needs to do, the typical case, the most ideal case will be of no infection, right? That if you have been vaccinated, you shouldn't get infected at all. That's the ideal case. But even if, let's say, you get infected and there are no symptoms, it is asymptomatic, then still it's fine. It's still something that you can manage. And even if, let's say, there are only moderate symptoms, even that works. So if the vaccine is able to do all that, that's good. That's good enough for us. Vaccine should be able to prevent against the death of a person or hospitalization or severe symptoms. That should be an exact practical rule of a vaccine. And when we test for all these, more or less you can say that all these have been giving almost 100% results. And that's why many a times the efficacy numbers may not be the correct numbers, because when we test the efficacy rates against death and hospitalization, this is where we see that all these vaccines, although they have shown various numbers, they have shown very varied numbers in the actual case of infection versus no infection, but in case of their efficacy rates against death and hospitalization, they all have shown almost 100% results. So that is ideal and that's good enough. And that's why we have seen that even in cases of the Delta variant, for example, where it became the deadliest version of COVID-19, a vaccine like Covishield vaccine, which was supposed to be not good enough in its efficacy rate, came out to be better in terms of Delta variant as compared to the mRNA vaccines, which were showing better results in efficacy rates. So when it comes to the real scenario, we saw that Covishield actually did better than the mRNA vaccines in these cases. So that's why these are areas where we need to understand that not everything that the figures are posting perhaps are the best judge of what is the reality. So any question if you have from whatever we discussed until now? Any question? What kind of questions can come from efficacy? It could be simple question based on the definition of efficacy or what it means and what it does not. Two questions. Deepshika, you are saying what two questions can you specify? What are the pros of Sputnik V? It's a recombinant vector vaccine, so chances are higher that it can generate a better immune response. So that's why efficacy rates have been seen to be higher. Can we say adjuvant as attention seeker? Yes, it's a perfect way to say it. What is placebo? Placebo basically is when you have something where you have been told that you have been given a medicine or a vaccine, but in reality you haven't been given anything. So maybe something, let's say I give you a tablet, all right, I say that look, this is paracetamol, you take this paracetamol and your fever will go away. In reality perhaps I gave you nothing. In reality that was not actually paracetamol, I maybe just gave you a sugar tablet and nothing else, but I told you that this is paracetamol, you also believed that this is paracetamol and you ate it. So that is called as placebo, and sometimes even placebos work, and that is called as placebo effect. We say that, and I'm going to make a controversial statement, we say that homeopathy entirely works on placebo effect, that you're not actually being given anything, but yet it works because you believe strongly that you have been given a vaccine, and in that placebo effect many a times it works. I'm not saying it, people say this. Do we need to know vaccines in current affairs? The basics of vaccines, I would still say, could be important even this year. So, yes, some of the things, any developments, if we see any news that we see, we should be aware of it. Serial killers equal to active killer T cells? Yeah, more like assassins actually, because they are waiting for their mark. Is it because of adjuvants that we have fever after getting the vaccine? Not exactly. It is mainly because of the fact that the immune system has started responding, and that immune system response is what creates the fever. Vaccines are also given after getting infected. Not really, it will always be given before the pathogen starts infecting, because they can only prevent the future, they cannot prevent the present. Subunit vaccine not understood. So in case of subunit vaccine, what we are doing is that we are only using a part. Suppose that there is only one part of the pathogen that acts as an antigen, so then instead of using the entire pathogen, we are just using that part. Suppose that there is a particular protein. All right, there's a particular protein in a given microorganism that acts as an antigen. So we'll only take out that protein from that microorganism and use that protein only instead of using the entire pathogen. So that's why subunit, because you're just using a part of it. mRNA vaccine was in use for sickle cell diseases. Yes, it was. You're correct. At the time of COVID, I have seen on newspaper two terms deaths. One is COVID death and another one is comorbidity. What is comorbidity? So, in case of comorbidity, the meaning is that there are other problems that persist because of you can say ineffective immune system. That immune system starts becoming weak, and that's why the other diseases that prevail in the body, they start to infect the body and they start to weaken the body altogether. So unfortunately, many of the people who died, they did not die of COVID-19 infection, but because of COVID-19, their immune system started becoming weak, and other diseases, they started to take an effect, and that became the cause of the death of that person. So that is called as comorbidity. Assignment link नहीं मिल रही. Assignment link. Which assignment are you talking about? The nanotechnology assignment? Please let me know. Who are those people on whom clinical trial is being taken? What if there is any negative consequence? Actually, there have been cases of negative consequence. So what happens is that in a lot of cases, the companies will call upon for volunteers who will come and participate in the clinical trials. And many times they just want to hurry up through the clinical trials so that they can release their vaccine or medicine in the market. And but before that, they have to show the clinical trial results. So that's why they try to hurry up through the process, and that unfortunately has had negative impact. There have been cases where people have died in clinical trials as well, where they fudged their reports. So for example, there was a case in India, I think it was a case in Hyderabad, where there was one person who died after participating in one of the clinical trials. Now when further investigations were done on his death, what they found is that the person had given wrong information to the company which was conducting the clinical trials, and the company did not do any background check. The person who lost his life, he used to go for clinical trials because they pay you in those clinical trials. So that was a source of income for that person. Now this person did not specify, although in the questionnaire it was asked whether you have gone to another clinical trial or not. He specified that he had not. Also, the clinical trial was supposed to be for people who are below 45 years of age. He had written that he is 38 years old. In reality, I think he was 52 or 53 years old. Now, nobody checked this. It would have been a simple case of checking the Aadhaar card of a person or checking the identity of the person, and you would know. And by looking at a person, you would know whether the person is 38 versus a person being 52 or 53. But unfortunately, all these things, all these background checks were not done, and that person lost his life. So these things do happen, and then the steps are taken, and all those things happen. But it should have been checked at the first case itself. In mRNA, the pathogens in form of RNA are injected and then the immunity system works. Yes, not the pathogens. No, no, not the pathogens. mRNA will be injected. Messenger RNA will be injected, and messenger RNA, once they enter the body, they start making proteins inside the body, and then that protein acts as an antigen. Is it important topic? I mean, should be important. That's why I'm teaching. Please glance once whole pathogen vaccine. So whole pathogen vaccine is when you are using the entire pathogen. All right. When you are using the entire pathogen, that's a whole pathogen vaccine. So either you kill the virus and then inject it in the body, or you weaken the virus and then you inject it inside the body. I was about to say the same for homeopathy. Yeah, I know many people say it has been effective. For many people, homeopathy works a lot. Placebo means playing with the mental state of people in a manner, simply making them fools. Yeah, true. Osteoarthritis is degenerative disease or deficiency. It is degenerative because it is something that happens largely with age and not because of deficiency. Deficiency will call something as deficiency if it happens also in the people who are young and they have a deficiency. But what happens with age is that our body's ability to use vitamin D or use calcium for making bones starts to diminish, and this is when osteoarthritis or osteoporosis etc can happen in the body. So that's why we'll call it as degenerative disease and not deficiency. Does AMR also happen through vaccine? Not really. We haven't really seen cases of that. Please explain APC. APC means antigen presenting cells. These are the cells that are there in our body, which will uh, help in catching hold of the antigens, and they will take the antigens to the helper cells. Benefit of higher efficacy with Sputnik V. I mean, higher efficacy means that it should be safer and should be more effective. It was with regard to Sputnik Light. Yeah, Sputnik Light is a nasal vaccine. That's correct. Any reference material being shared that we might have missed besides radioactive elements? No, nothing else. No, nothing else I've given. Is patent a challenge for vaccine distribution? We'll discuss this. There is a news event today about this, and we'll go to the chapter of IPR, and there we'll discuss it tomorrow. How were the corona patients treated without a vaccine? We just, all the infections that they had, all the symptoms that they had. In general, when it comes to a viral disease, you treat for the symptoms instead of for the exact disease. Many of the cases of viral diseases, this is what we do, and this is what we try to do. Difference between antigen and antibody, completely different. They are completely different. Antigen is going to harm the body, might harm the body, and antigen is produced against the antibody, sorry, antigens. The assignment link is there itself. I mean, below that assignment question there is the link. If you click on that link, you will get to the required article. If that doesn't happen, let me know, then I'll share the article separately. Positive mindset or attitude can help to cure our diseases. Example is placebo effect. There are actually studies on this, and very interestingly, it has been found so that if there are believers in their process, their treatments, if they have a will to live and will to survive, they do. It actually has been showcased in some of the studies. Difference between RNA and DNA vaccine, because one is using DNA, one is using RNA. That's the basic difference. Herd immunity is when you are providing immunity to a large community so that it can take care of the disease altogether. Homeopathy has a great effect. Yes, that's why I told that homeopathy works wonders for a lot of people. and it has been able to do a lot better in certain cases compared to allopathic medicines as well. So that's why there are a lot of people who regularly are users of homeopathic medicines more than allopathic medicines. Cancer, no vaccine. Yeah, that's true. Cancer still doesn't have a vaccine, although there are treatments that are available now, but yet there are certain issues that we have. How ethical, how ethical that we trail or do trials on humans, and what if it affects their life? So they would be these are voluntary participations. You are not being forced into it. You are being asked, and if you are ready, only with your permission, this is being done. So, and that's why you sign all the legal contracts and documents before you do that. The link of the assignment is not working. I checked right now. Fine. I'll after the class I'll check that. Both mRNA and RNA vaccines are same. mRNA vaccine is a kind of RNA vaccine. So coming to our next discussion, this is about defense. Now, in terms of defense, this again is a chapter which is largely important from the perspective of current affairs. There are some basics that we should know, but beyond that, I expect questions to come largely from the current affairs rather than the static areas that we are discussing here. And one of the most important ways to study this chapter of defense is through DRDO website. In on when you go to DRDO website, all right, when you go to DRDO website, there is one section called as publications. So go to publications, and in publications you will find DRDO newsletter. All right, DRDO newsletter. So just go to DRDO newsletter, and this DRDO newsletter basically is a downloadable PDF document, a monthly downloadable PDF document, which consists of 20 to 24, 28 pages every month, out of which only 2 or 3 pages are related to something new that was done by DRDO, a new test missile fired, or maybe a new technology which has been, let's say, bought by India, or some new development somewhere, some modification somewhere. So there will be 2 3 pages. If you are lucky, only 1 page. If you are unlucky, maybe up to 4 pages. But these 4 pages, these 3 4 pages every month, they become very very crucial, because they give you the topics from where, if they are asking questions, these are the topics from where they can ask questions, because these are the biggest things that have happened. So for example, these are cutouts that I've taken from March 2024 newsletter. As you can see, page number 9 and page number 10. So they have published these. So successful flight trials of high speed expendable air targets abhyas, this has been done. So overall, so something like this. So what these trials are, what is the objective of these trials, what are we trying to achieve, these kind of things will be written in these kind of articles, these articles. Similarly, digital flight control computer for Tejas Mark 1A flown successfully. So now you know that Tejas has been constantly in the news, and this month it is supposed to be available. So that's why it is very significantly in the news constantly. So that's why anything related to Tejas can also be important. So that's why these kind of articles will be there in this newsletter. So this becomes one stop destination for you for every news related to defense. Now other pages will be of no use. It will just be about all the conferences that happened in DRDO, all the festivals and functions and seminars that was conducted, all the cultural fests, etc., that were conducted at various offices of DRDO. So it will just be about all that. So most of the newsletter is junk for you, but there will be 2 3 pages, maximum of 4 pages, where these kind of articles are published every month once. Go through these. If you just do this, it's enough. But do this, it will help you. Now Coming to this chapter, there are few things that become important. First of all, it's about missiles. So what do we first mean by missiles? Now missiles, what we say is that these are rocket propelled weapon designed to deliver an explosive warhead with great accuracy at high speed. Now this warhead, that we are delivering, it could be chemical, it could be biological, or it can even be nuclear. Right, so a warhead that can be used also largely in offensive ways, but also in defensive ways they can be used. So that is typically what a missile is. So this is how generally a missile would look like, that you have this part which is the warhead, this is the warhead. All right, this is the warhead, or you can say that this is the payload in the context of a missile, and this is the part which is called as the launcher. This is the part called as the launcher. So you have the launcher and you have the warhead. Now this is what typically a missile is. Now a missile can be classified in various different ways. So there are four primary ways in which we classify a missile. So understand how. First, on the basis of range. So on the basis of range, meaning how far can they travel. So depending on that, there are short range missiles, medium range or intermediate range missile, long range missiles, and intercontinental range missiles. So this is how we define them on the basis of their range. Short range could be in the let's say 10 kilometers, 50 kilometers, 100, 200 kilometers generally will be called as short range missiles. Then up to 1000 kilometers, generally they'll be calling them as intermediate range missiles. Then long range missiles may be up to 3000, 4000 kilometers, and beyond that, I not even that, let's say up to 2000 to 3000 kilometers, and beyond that we'll call them as intercontinental missiles. And why intercontinental? Because they can travel between continents. That's why intercontinental missiles. So this is how we can classify missiles, on the basis of range. Then on the basis of the start and the end point, they can be surface to surface, surface to air, air to surface, air to air. So that's why depending on the start and the end point, they can be classified in these four ways. Then the most important way to classify missiles is on the basis of their trajectory. So trajectory or path of the missile. So on this basis, we have ballistic missiles and cruise missiles. Ballistic missiles and cruise missiles. So just try to understand the basic difference between what do we mean by ballistic missiles and what do we mean by cruise missiles. So you have ballistic and we have cruise. So the basic difference is in their path. So as you can see that the ballistic missiles, they are taking a parabolic path, right? This is a parabolic path. And in case of cruise missiles, as you can see that they basically have a path like an airplane. They have a controlled path just like an airplane. So how you control airplane, you can actually control the flight path of cruise missiles. But in case of ballistic missiles, we don't control the path. It will be just like how you, let's say if you have a ball in your hand and you throw a ball, so the kind of trajectory that the ball will take, that kind of trajectory will be taken by a ballistic missile. So you pre-decide and you fire in ballistic missiles, whereas you can control in case of a cruise missile. So that is the first difference between the two. That ballistic missiles, they have parabolic path, whereas in case of cruise missiles, they have a path, or you can say airplane like path, airplane like controlled path. So that's the first difference between ballistic and cruise missiles. The second difference is on the basis of range. We generally see that ballistic missiles, they have longer ranges, they have a longer range, And in case of cruise missiles, they have shorter range. They have shorter range. That's the second difference. Then the third difference, ballistic missiles, they have more destructive capacity, more destructive capacity, whereas in case of cruise missiles, they have less destructive capacity. They have less destructive capacity. So that's another difference that we have. Now, overall, it might so seem that because they have long range, more destructive capacity, parabolic path, and also they are faster, and these are slower. Now, until now, you might say that ballistic missiles are better, right? Ballistic missiles are better because they have a longer range, they have better destructive capacity, they are faster, so they should be better. But there is one very important aspect where ballistic missiles lack and cruise missiles are better, and this is accuracy. They have lower accuracy because they do not have a controlled path, they have a prefixed path, and in case of cruise missiles, they have higher accuracy. So that is one aspect where cruise missiles are pretty important and they actually are better in that sense. So this is where we see that ballistic missiles will have lower accuracy. Then even in terms of capacity, you can say that as we are saying that they have more destructive capacity, their carrying capacity altogether is also higher. And generally there is one more difference, that these are, I'm just writing, notice the term generally, that they are generally strategic missiles. They are generally strategic missiles, and these are generally tactical missiles. And I'll tell you what tactical means. Generally these are tactical missiles. All right, so that's another difference that we have between ballistic and cruise missiles. So in this manner there are all these important differences that we see between ballistic and cruise missiles. And to define a missile, this is the most important parameter to differentiate or define a particular missile, that whether it's a ballistic missile or whether it's a cruise missile. Now, one last classification that we have is on the basis of utility, where we have strategic missiles and tactical missiles. So now again, strategic missiles are the missiles that are strategically important for a country. All right, strategically important. Strategically important for a country. How strategically important? They are long range missiles, so they have long range, they are nuclear capable, nuclear capable, they generally would have high destructive capacity, and they also have something called as second strike capacity. All right, they would also have second strike capacity. Second strike capacity. Now, when we say second strike capacity or second strike, let's say, let me call it capability. Second strike capability. What we mean is that they have a capacity to strike after being struck, that you can use them to launch an attack after being attacked. So that's why these can help in attacking. So can attack after the country has been attacked. So that's why they would be kept in off locations, locations that are not known, maybe in the submarines, maybe in the entirely hidden areas. So that's why they would have second strike capacity, that let's say somebody has launched an attack on us, to strike back will be using these missiles. So these are strategic missiles. And on the other hand, we have tactical missiles. Tactical missiles are the missiles that are used in battlefields. These are missiles which are actually used in battlefields. So they would be short range, very highly accurate, and they'll be used during a war. Most of the times, they'll be used during a war. So that's why they are used in battlefields. So these are called as tactical missiles. And that's why you can say that strategic missiles for a country are largely for show off. That we want everyone to know that, look, we have these missiles. That we have missiles which are nuclear capable, we have missiles which are very high destructive capacity, they have very long ranges. So we just want to announce that look, China, look, Pakistan, we have all these things, so you better not attack us. And that's the basic reason why do we even have strategic missiles. While we may not ever use a strategic missile, but we still need to have them, just to have the capacity, just for that bad day where you are actually being attacked, or maybe in some way or the other you are actually in a war. So then in that case, strategic missiles can actually become important in these kind of cases. And that's why we have so much of defense capability, that even when, I mean, you might see that every now and then there is a missile uh, test that happens. Agni 5 tests happened very recently again. So these kind of tests, they keep on happening all the time, but yet we never use it in the real time scenario. It's not that because we have all these missiles we keep launching it casually on Pakistan or on China. We don't do that, and we would never do that, right? So just that we have these missiles, we have this power to ensure that we are safe, to just ensure that everybody else also understands that we are capable in the age or on the day of the war. So that is basically what we want, that everybody should just understand that we have all these capabilities. Now, based on all these, we see that there is the integrated guided missile development program that was started by India back in 1983. And as a part of this program, we started building missiles for the first time. For the first time, we started building missiles. And as a part of this system, there were 5 types of missiles that were made by India. Can you tell me the names of these 5 types of missiles? Which are these 5 types of missiles? Yes, Agni correct. Akash correct. Prithvi correct. Yes. So you have given all the correct answers. So there are 5 missiles that we have. So you have Prithvi. You have Prithvi missile. So we made 3 versions of Prithvi missile. One for the Indian Army, one for the Air Force, and one for the Navy. So 3 versions of Prithvi missile. And then after that, there are 5 variants of Agni missiles now. There are 5 variants of Agni missiles, and recently also Agni missile has been in the news. And in case of Agni missiles, we see that with Agni 5 that we have now, we have a capacity that goes up to almost 5,500 kilometers, up to 5,500 kilometers, which is significant. Although China claims that India has a capacity of up to 8,000 kilometers with Agni missiles, just that India is lying to the world and not telling about the exact truth about Agni missiles, that Agni missiles have 8,000 kilometers capacity. Now, why do we not announce? Why do we not announce that, okay, we have a missile that has a capacity of going up to 8,000 kilometers? Because 8,000 kilometers simply means that you are covering the entire Europe, right? You're covering the entire Europe. You can go to Australia, you can launch your attacks to all these countries. We do not have any animosity with these countries. So that's why when we announce that, look, we have these missiles that can go up to 8,000 kilometers, because almost a decade back, or rather more than that, almost 14, 15 years back, there were talks of Agni 6 missiles, that India might start working on Agni 6 missiles, and Agni 6 missiles would have a capacity to go up to 10,000 to 12,000 kilometers. As soon as this happened, India started landing controversies. European nations, they started questioning, why do you need these kinds of missiles? You do not have anything against us. You are not enemies of Europe. Then why do you need missiles that can go and launch attacks against the entire Europe, or maybe in the Americas as well? Why do you even have these missiles? So these kind of controversies happened. India said that no, no, these are all rumors, and there are no such missiles that India has. It is said that India might have these missiles, but we will never announce it openly whether we have it, because then it lands us in controversies, that these countries start saying that why do you need these missiles? Although the fact is that these countries have these missiles that can launch an attack against India. They have capacity to launch an attack against India. So we can also question the same, that why do you have these missiles? I understand you don't want us to have these missiles. Why do you have these missiles? So when they have it, it's fine. When we have it, it's wrong. So unfortunately, this is the state of the world. So Prithvi missiles, Agni missiles, then we had Trishul missiles. Now, Trishul was discontinued because there were a lot of failures in the testing of Trishul missiles. So that's why this was discontinued. And there is a missile called as Barak. Barak missiles that we bought from Israel. So that first it was Barak 1, and then later it was Barak 8. So these missiles were bought from Israel, and these are replacements, like to like replacements for Trishul missiles. Then there are Nag missiles, and these Nag missiles are anti-tank missiles to be used against tanks, can be launched via various different platforms, from a stable platform, a stationary platform, as well as a mobile platform, as well as a helicopter. The helicopter variant of Nag is called as Helena. Helicopter Nag. So Helena is the name given to it. So, and then lastly, we have Akash missiles. So, Akash missiles are largely defensive in nature for anything that is incoming. They are also fitted with a radar so that they can catch anything that is incoming, and they can launch an attack against the incoming aircrafts or missiles. So, this is how these are the 5 types of missiles. So, that's why an acronym to remember: the beloved city of Patna. PATNA, Prithvi, Agni, Trishul, Nag, and Akash. So these are the 5 missile types that we started building, and now we have developed all these as a part of integrated guided missile development program. Now beyond this program also there are other missiles. For example, the most important missile here is BrahMos. Now BrahMos, the first variant of BrahMos, a short range missile with 290 kilometers as the range, and it's a supersonic cruise missile. Now, this is very, very crucial, that BrahMos missiles are supersonic cruise missiles. Now, why being supersonic cruise missile is important? If you remember, let me go back to that slide. We discussed that the cruise missiles are slower, right? Cruise missiles are slower. So they largely are subsonic in nature. Oh, my water is gone. So they are largely subsonic in nature. They are not, very rarely you will find that something is beyond subsonic. And India has a cruise missile which is supersonic. That's BrahMos. And BrahMos, that's why BrahMos is said to be one of the fastest, if not the fastest cruise missile of the world. So BrahMos missile has a capacity of carrying warheads of up to 300 kilograms, and it can reach supersonic speeds of Mach 2.8, up to 2.8, with a range of 290 kilometers. Now, the reason why the range is 290 kilometers and the supersonic speed of up to Mach 2.8 is mainly because when BrahMos missiles were being developed, India was not a part of MTCR, Missile Technology Control Regime. So we were not a part of MTCR back then, and later we became a part of MTCR. So since when we were not a part of MTCR, we were not allowed to have a missile that has a range beyond 300 kilometers, because this is also a joint venture with Russia. Russia, which is a member of MTCR. So since we have a joint venture with Russia and we are developing these missiles, we were not allowed to have a missile that has a range beyond 300 kilometers, or a speed beyond 3 Mach. So we have to be below Mach 3, we have to be below 300 kilometers range. And that is why we had these numbers. But then we became a part of MTCR back in 2016. We became a part of MTCR. So once we became a part of MTCR, that is Missile Technology Control Regime, once we became, this is where BrahMos Mark II or BrahMos 2 missiles is what we have started building. And now it has a range of up to 450 kilometers with speed of up to max 7. So going up to hypersonic speeds this time, which is going to be faster than BrahMos missile, which is supposed to be the fastest cruise missile of the world. So BrahMos 2, that's why, becomes the fastest cruise missile of the world. This is a prototype of the BrahMos missile, which is under development right now. And we are also going to use scramjet here. It will be propelled by a scramjet air breathing jet engine. If you remember, we discussed about scramjet, where instead of carrying oxidizers, we'll be using oxidizers from the outer atmosphere. So that is where scramjet will be helpful in making it lighter, and that's why it can be carried longer distances. Then there are missiles under Indian Ballistic Missile Development Defense Program. Now, this is where we are building a defensive mechanism or a shield with the help of anti-ballistic missiles. So there is a two-layer shield that we are trying to build, and this is where we have Prithvi Air Defense and we have Advanced Air Defense. Prithvi Air Defense for exo-atmospheric range and Advanced Air Defense for endo-atmospheric range. All right. So Prithvi Air Defense and Advanced Air Defense. So this is a two-tier system that we are building so that we can cover the entire air and we can launch an attack against anything that is an incoming aircraft or a missile. Just like if you have heard of the Iron Dome that is there with Israel and how they are able to protect themselves against attacks launched by ballistic incoming ballistic missiles. So similarly, we have been building this defense program and has been under development for quite some time now. We started testing them back in 2006 and 2007. First successful test of the Prithvi air defense was done in 2006, and for the advanced air defense it was done in 2007. And since then there are further tests that have happened, further improvements that have been done, and now it has been said to be ready for being inducted into the Indian defenses. Then there is the AD1 missile as well, and this AD1 missile also is a defensive missile against ballistic missiles. So that's why there are all these developments as a part of the defensive programs that we are trying to build. Then another technology that of late has been in discussion a lot has been radar. Now radar stands for radio detection and ranging. What we do with the help of radar is this, that we would have a system where you have a transmitter, and you have a receiver. You have a transmitter and you have a receiver. The transmitter basically will transmit microwaves, largely microwaves, sometimes also a mixture of radio waves. So largely microwaves will be transmitted, and these microwaves, when they are transmitted, they would basically go and reflect back from the target. So basically, let's say there is any aircraft, suppose that there is an aircraft that is flying, and now these microwaves, they will go and they would collide with it and they will deflect back. All right, they'll go collide and reflect back. So now what happens is the entire movement can be tracked, because these microwaves, they are being sent in all the directions. So that's why they will be able to track the entire movement, because you already know the speed of the microwaves. It is similar to the speed of light. So it we know the speed, we know the time it took to go and reflect back. So time, you know, distance, sorry, time, you know, speed, you know, you can calculate the distance. So distance can be calculated, hence the entire pathway, projection of the entire pathway can be calculated on the basis of what you are transmitting and what you are receiving. And once we receive these signals back, it goes to the decision making unit, from where we will try to understand and figure out the pathway of any incoming missile or any incoming target. So that's why this is how any given radar system would work. These are the basic parts of any given radar system. Now, in the context of radars, there is another technology that has been in the news a lot, and this is the stealth technology. Now, stealth technology is where we are making the use of uh, a technology in a manner that it can bypass any radar. All right, it can try and it will succeed in bypassing a radar. So there are various mechanisms that we use uh, so that they can bypass the radars. So, for example, if you look at this picture, what you'll see is that it has very sharp edges, right? It has very sharp edges, it will have flat surface. So there are all these things, plus it will have a very dark or practically black color, and it will use various different materials, specific materials, that can also ensure that it can absorb the radiations as well. So there are all these aspects that we ensure in any given stealth technology based aircraft. So this aircraft will have flat surface, they would have flat surfaces, they would have sharp edges, right? They would have sharp edges, then they would have wave absorbing material, wave absorbing material, and black color. So these are certain things that we do to ensure that the stealth technology can work, and stealth technology can ensure that it can bypass any given radar. So there are all these techniques that will be used to ensure that they will be able to bypass the radars. So overall, that's why we see that there are these aspects that will be taken care of. So any question if you have from all the discussions that we did? Also, okay, just one question. This was asked in your paper. Just go through this question, please. It's an easy question. I'm launching the poll for you. Please mark your answers. Hmm. So it's kind of an even distribution, but 36% of you have marked D, which is the correct answer. Look at the question. We have discussed everything. First is ballistic missiles are jet propelled at subsonic speeds. What did we discuss? Ballistic missiles are faster, and cruise missiles being supersonic is a big achievement. Generally, ballistic missiles are faster, so they are supersonic. This is wrong. Throughout their flights, and while cruise missiles are rocket powered only in the initial phase of the flight. No, you control the path. What did we discuss? That cruise missiles are like airplanes, so they are not ignited only the initial phase. That's what happens with ballistic missiles. So first part of the sentence is also wrong, second part is also wrong. Then second statement, Agni 5 is a medium range. It's a medium range supersonic cruise missile. It's not medium range. What did we discuss? 5,500 kilometers, and China claiming that it is up to 8,000 kilometers. It cannot be medium range. Medium range is 1,000, 2,000 maximum. So this is going way beyond that. So supersonic cruise missile, it's not even a cruise missile, it's a ballistic missile. While BrahMos is a solid fuel intercontinental ballistic missile. Completely wrong. It is not a ballistic missile, it's a cruise missile, and not intercontinental. It's a short range missile. So nothing that has been given in these two entire statements, anything is not correct. Nothing is correct. So that's why this is the correct answer will be neither one nor two. That's why I said that it was an easy question. It's completely based on all the things that we discussed. All right, so any question if you have from here before we move forward? Repeat radar mechanism point. So radar mechanism, just understand this, that when we are talking about the radar mechanism, hmm, in radar mechanism we are saying that first we transmit the wave. So we will transmit waveforms, mainly these will be microwaves, and these microwaves will go, they will reflect back from the aircraft or from the missile. So while it reflects back, it will take some time to go and come back. We can calculate that time, we know that time rather, that how much time did it take for the waveform to go and come back. And then we already know the speed of these waves will be similar to the speed of light. So we know the speed, we know the time, we can calculate the distance. So that's why we'll know at what distance these aircrafts lie. Only was a big hint. Okay, in this particular scenario, see, I would not even say that only was a big hint, because what they did is they just have done the reverse of what is correct. So, for example, ballistic missiles are are the rocket powered. They are rocket powered only in the initial phase. So this is correct. And then cruise missiles, they basically are jet propelled at subsonic speeds generally. So that's so opposite of what's correct. Similarly, in case of BrahMos, we can still say that it becomes a supersonic medium range missile, because for a cruise missile to be 450 kilometers is good enough. And BrahMos, and Agni 5 is an intercontinental ballistic missile. So that's why they have just flipped everything and given it here. What does accuracy mean in case of missiles? Generally speaking, that when we talk about accuracy in missiles, accuracy would be if they can land in a range of not more than, let's say, um, uh, 10 meters, 20 meters, or 50, 100 meters in range. So up to 100 meters, we'll say that these are highly accurate missiles. Cruise can change the can change path on command. Yes, this is correct. They can change their paths on command. Solid fuel means that they are using solid fuel, just like, for example, coal is an example of solid fuel. It's not that they use coal, they would use something like HTPB, etc. 290 kilometers in BrahMos missile is a medium range. No, but 450, in that case we can still say that it's medium range. And in the case of cruise missiles, generally what happens is that cruise missiles would have a range of 10 kilometers, 20 kilometers, 50 kilometers. So in the context of cruise missiles, 200 kilometers or 500 kilometers is a very nice range to have. Generally you will not find cruise missiles having that high ranges. So that is why we see that this is how they are different. How many classes left? Today and tomorrow, these are the two classes left. Hmm. So before we move on, why can't Pakistan detect presence of BrahMos in its airspace? Because they do not have any systems like these, and it becomes very difficult for them to do that. And even for the radar systems to detect, they need to have state-of-the-art radar systems. Because of the missiles that we have today, they are not very easy to detect, and if especially if they are traveling very low in the atmospheric range, then for them it becomes very difficult to strike it back or even detect it easily. Supersonic means above the speed of sound. Supersonic. Subsonic, less than speed of sound. Supersonic, more than speed of sound. What is ballistic? Ballistic is, as I just told you, that these are missiles which have predefined parabolic path. Does China have all the technology that we have? More or less, yes, they do. So let's take a break here, and it's 6:36. So let's be back by 6:50. Let's be back by 6:50 p.m. and we shall continue our discussion. Welcome back, everyone. The next chapter that we have is IT and communication. Now, when it comes to this chapter, this is a chapter which I'll say is more important from prelims perspective than mains. If you look at the questions also, you'll see that the number of questions in the past few years have increased. And now we see that almost every year one question does come, and sometimes even more than one question. We have seen two or three questions have also come in the paper. So, this chapter of IT and communication, and what exactly are we reading here? So when it comes to IT and communication, this as a chapter is also a very different chapter as compared to many of the other chapters that we have been discussing until now. So for example, in most of the chapters there is just one topic and we have been discussing various aspects of that one topic. But in this chapter there are various things that we are going to discuss, and you can say in a manner it's a bunch of topics taken together. We'll discuss about various different types of wireless communication, that what is bluetooth, what is wi-fi, what is rfid, etc. Then what is 5G, we'll discuss about that. And then we'll discuss blockchain technology, supercomputers, quantum computing. So there are various different things, internet of things. So we'll discuss all that, and all these are, you can say, independent topics, right? All these are independent topics, and we'll discuss all of them one by one. To start with, we need to understand what do we mean by wireless communication. Now, as the name suggests, this is wireless communication, meaning that you do not need wires for this kind of communication. Now, there are different types of wireless communication: Bluetooth, NFC, RFID, Wi Fi, Li Fi. All these can be taken as examples of wireless communication. Now, when it comes to wireless communication is done with the help of electromagnetic waves. Now, when we say electromagnetic waves, what is the meaning of electromagnetic waves? And second question is, why do we use specifically electromagnetic waves for wireless communication? Now, when it's produced when electric wave field comes in contact with magnetic field, meaning that when there is electric field, it can induce magnetic field. Wherever there is magnetic field, it can induce electric field. They can exist together. And the waves that have electrical properties as well as magnetic properties, these are called as electromagnetic waves. All right, so that's why they have both electrical and magnetic properties. They have both electrical and magnetic properties. So these are electromagnetic waves. Now the question is, why electromagnetic waves? Why do we use electromagnetic waves for wireless communication? Why do we use electromagnetic waves for wireless communication? There are two basic reasons that you have to understand. That the first reason is that they travel very fast. They travel very fast. So they would have the speed of light. So you can say that they travel with the speed of 3 into 10 to the power of 8 meters per second. So they travel very fast. And then the second reason is that they can travel even in vacuum, meaning that they don't need a medium to travel. They don't need any medium to travel. So for example, let's say sound waves, they need a medium to travel. In the absence of medium, even either they need air or maybe a liquid, maybe a solid. So they need some kind of medium in which through which they can travel. Whereas in case of electromagnetic waves, they can travel in vacuum. They do not need any medium to travel. Between the sun and the earth, there is no medium. After our atmosphere and before sun's atmosphere starts, there is no medium. Yet light comes from the sun and reaches the earth. And the speed is also not bothered, and speed will also remain the same, and it travels very fast. So these two become primarily the reasons why electromagnetic waves are used in why they are used in wireless communication. Now, in terms of wireless communication, there are two terms or two concepts that become important for us before we proceed, because these are terms that will be very often used in the context of this entire chapter. So we'll try to understand what do we mean by wavelength and frequency. Now, wavelength and frequency, these are two terms. Now, wavelength in the context means distance between two consecutive peaks of a wave or troughs of a wave. Meaning, you can say in a manner, two similar points in a wave. So, for example, the distance between this point and this point, this will be called as wavelength. Similarly, the distance between this point and this point, it will be called as wavelength. The distance between this point and this point can be called as wavelength. So any two similar points, the distance between any two similar points will be called as wavelength, length of the wave or wavelength, and that's why it will be measured in meters or maybe fractions of meters, like millimeters, micrometers, nanometers, and so on. So it will be measured in meters because we are covering or we are measuring distances here. So that's the first concept of wavelength. The second concept is of frequency. Now, when it comes to frequency, we are saying that this is nothing but the number of waves in a given length of time. Number of waves that are formed in a given length of time. Now, in this context of number of waves in a given length of time, what do we mean? How many waves can pass in any given unit of time? Just understand this. Suppose that we start from here. Right? Suppose that we are starting from here and we are ending here. And this is the time period of 1 second. This is the time period of, let's say, 1 second. Now, if I ask you, can you count the number of waves in the first case, the upper case? Can you tell me how many waves are passing through this region in 1 second? Can you count the number and tell me? Yes, it's three. Three waves. Here to here, 1, 2, 3. There are three waves here. All right. So three waves are passing through in this one given second. If I ask you the second case, so here we are saying that there are three waves which are passing through. In the second case, can you tell me whether it is, how much is it? Yes, it's one. So only one wave is passing through. Now, in these two cases, if you see, the first case has a shorter wavelength. It has a short wavelength because the space between two consecutive points in a wave is less. And the second one has long wavelength because the space between two consecutive points is more. So that's why it is a long wave. It has a long wavelength. So short wavelength and long wavelength, these are the things that we see right here. Now, overall, when it comes to the short waves and long waves, what you see is that in case of short wavelength, more waves are able to pass through in one given second, whereas in case of long wavelength, less waves are able to pass through in a given time period. So what it means is that when you have short wavelength, you have high frequency, and when you have long wavelength, you have low frequency. So frequency and wavelength are inversely proportional. All right, these are inversely proportional. If one increases, the second would decrease. This is the relation between wavelength and frequency. So now, in this regard, when we look at with this concept, so frequency is measured as number of wave cycles per second, which is also called as hertz. So unit of frequency is hertz and unit of wavelength is meters, because it is nothing but the distance being calculated between two similar points on a wave. Now, when we look at these two parameters, this is what would start defining the different types of electromagnetic waves. Now, we discussed that electromagnetic waves, these have electrical and magnetic properties. There are different types of electromagnetic waves based on their wavelength and frequency. Now, if you arrange it from short wavelength to long wavelength, what you see is that you have gamma rays. If you remember, we had discussed about gamma rays in nuclear technology, right? We had discussed it in radioactivity, gamma rays. So gamma rays, gamma decay, gamma radiation, gamma particles, all those things mean the same thing. So gamma rays basically are a kind of electromagnetic radiation which have the shortest wavelength, shortest of all the electromagnetic waves. These are the shortest wavelength. And then after gamma rays, you have X rays, then you have ultraviolet, then after ultraviolet come the visible light, then you have the infrared, then you have microwaves, then you have radio waves. So radio waves have the largest, they have the longest wavelength. So this is how we see all these different types of waves. These are the different types of waves. Now in this particular scenario, we see that from when we have short wavelength, obviously frequency will be high. So you have highest frequency in gamma rays and you have lowest frequency in radio waves. But apart from wavelength and frequency, there is another parameter. There is the third parameter also, which is connected to the concepts of wavelength and frequency. And that's the concept of energy. If you see and if you remember, we had discussed that gamma rays have extremely high amount of energy. They are very energetic. That's why nuclear reactions, gamma rays were becoming a source of energy. And we had discussed that they can burn the skin and tissues. They are used in killing the cancer cells. So because they have very high energy. So gamma rays have the highest energy, radio waves have the lowest energy. So that's why if we establish the relation between the three concepts, when you have long wavelength, when you have long wavelength, you have low frequency and you have low energy. And when you have short wavelength, when we have short wavelength, we have high frequency and high energy. All right. So this is how the relations are. This is how the relations are. Now, overall, that's why energy and frequency, these are directly proportional, and energy and wavelength, these are inversely proportional. So this is how we define them. Now on that basis, also understand that if we had to use a wave, let me just ask you a question randomly and then I'll give you the answer and the explanation to it. Out of all these different types of wavelengths that you see, all the different types of electromagnetic waves that you see, can you tell me which is the one that becomes the most suitable in mobile phone communication? Out of gamma rays, X rays, ultraviolet, visible light, infrared, microwaves, and radio waves, which is the most suitable for mobile communication? Perfect. As many of you have answered, radio waves. Now, can you tell me why? Why do you think radio waves? Why do you think radio waves are the most suitable? Long wavelength. Okay, this is correct. Long wavelength and low energy. Manikandan, you have given the perfect answer. So two things: low energy and long wavelength. Long wavelength would mean that they can travel very long distances, right? They can travel very long distances. So we use radio waves. We use radio waves for mobile phone communication, and for two basic reasons. One, that they have long wavelength, long wavelength, and second, they have low energy. Now, obviously, these two are related, but low energy would also mean that their dissipation of energy, they lose less energy as they travel. So they can travel very long distances without losing energy. So that's why they become useful. That we have satellites, we discussed that we have communication satellites that are put at 35,786 kilometers. So the waves have to travel from the earth to 35,786 kilometers and come back. And that happens very quickly, first of all, because they can travel very fast, they can travel long distances without losing energy, without losing a lot of energy. They lose very less energy. And because they have low energy, they also become useful because they do not cause any harm to humans. if let's say if let's say it was possible for us to use gamma rays, if we it was possible for us to use gamma radiations for mobile phone communication, would we still do that? We wouldn't, because they have very high energy, and that would mean that they can kill us. I mean, if we were using gamma rays as mobile phone communication, for mobile phone communication, we would not have been alive to see these classes, correct? So that's why radio waves become important in this particular scenario, that they have long wavelength, meaning that they can travel can travel long distance without losing much energy. They can travel long distances without losing what much energy. Low energy means that not harmful for humans and other life forms. So that's why these two parameters become very, very important. That why for wireless communication, largely you will see that for wireless communication, we prefer radio waves. Even if it was possible for us to use gamma rays, it would mean that we have to spend a lot of money, because they have very large, they will lose a lot of energy in traveling very short distances. So if you have to make them travel very long distances, you'll have to give a lot of energy, meaning you will have to infuse a lot of money into these kind of infrastructures. So that's practically not possible, even if they did not have all the other problems. Now, what we'll do is we'll discuss about all the different types of waves and how these waves are important. So, three things become important for any wave: their wavelength. Many a times in the examinations, we have seen that they have asked the wavelength parameters, their frequency, although frequency has not been asked frequently, but frequency becomes important, and their application. Where do we use them? So, these are three things that become important for any wave that we are discussing. So first is radio waves. Now in terms of radio waves, we are saying that they have frequency of up to 30 gigahertz and wavelengths that are greater than about 10 millimeters. Wavelengths greater than about 10 millimeters. And then radio is used primarily radio is used primarily for communications, including voice, data, etc. So we know that for largely for wireless communication, radio waves are the preferred medium. So whether mobile phone, radio, internet, television, all those things, we actually are making the use of radio waves. Then we have microwaves. So microwaves have frequency between 3 to 30, 3 gigahertz to 30 terahertz, and wavelength between 10 millimeters to up to 100 micrometers. So that's the range. And then they are used for high bandwidth communication. They are used for high bandwidth communication. They are used in radars, and they are also used in the microwave ovens, right? They are useful in microwave ovens as well. So they have all these applications, and they can be used in industrial applications also. And even if you remember, we had discussed about cosmic microwave background in space technology. So cosmic microwave background also has microwaves, because microwaves, just remember that they are associated with heat, where they can actually produce a lot of heat. That's why microwave ovens, because in the ovens you can cook the food, or you can heat the food at least with the help of these microwaves. So that's why microwaves become important. Then There are infrared rays. So infrared basically starts from 30 terahertz, goes up to 400 terahertz, and then the wavelength between 100 micrometers to up to 740 nanometers. All right, 100 micrometers to 740 nanometers. And this is where we see that they become, again, they are associated with heat. Wherever we have any source of heat, they would have infrared. So for example, even when you start running, or when you are doing any physical activity, when you are exercising, so when you are sweating, it means that there is heat being released by the body. So that heat being released also means that there are infrared rays also which are being released by the body. So that's why they become the heat signatures. They can be detected as heat signatures. Many a times in the night vision cameras they are used, in animal traps that we set up in the wildlife sanctuaries or national parks. In those camera traps also we make the use of the same infrared. So that's why infrared is important from this perspective. Then we have the visible light. Now visible light has frequency between 400 to 800 terahertz and wavelength between 740 nanometers to up to 380 nanometers. Now here obviously you know about visible light and why visible light is important. Our eyes can see the world, we can perceive the world because of this visible light. That's the only part of the electromagnetic spectrum that our eyes understand. We do not see infrared, we do not see ultraviolet, we do not see any other wave. We just see, or we can see with the help of the visible light. So that's why visible light becomes very crucial for us. And even communication systems can be designed based on visible light. We'll discuss about them later, but it's doable. Then there is ultraviolet. Now in case of ultraviolet, we have frequencies between 8 into 10 to the power of 14 to 3 into 10 to the power of 16 hertz, and wavelength between 380 nanometers to up to 10 nanometers. Now in this regard, when it comes to ultraviolet, ultraviolet is where we see that it is a component of sunlight. It is a component of sunlight, and with sunlight we see that ultraviolet reaches the earth. Ultraviolet would reach the earth with sunlight. Now in this ultraviolet also there are three types of ultraviolet: UVA, UVB and UVC. Now UVC is the smallest. This is the smallest, and wavelength is between 100 to 280 nanometers. So UVC is the smallest, and UVC is also the most harmful. Why? Because it has the smallest wavelength. Smallest wavelength means highest energy. Highest energy means the most harmful. So UVC is the most harmful kind of ultraviolet among the three types of ultraviolet. But all the UVC that we receive from the sun gets completely absorbed in the ozone layer. Ozone layer would completely absorb ultraviolet C, and that's why ultraviolet C does not reach the earth. So that's a good thing about the ozone layer, that it is able to completely absorb UVC. Otherwise UVC is the most harmful. But there are other man-made sources as well, that they are uh, there in welding torches, in mercury lamps, in germicidal UV lighting, etc. We actually have them. So welding torches also, you might have seen that people would keep a shield wherever they are doing welding, because there are a lot of ultraviolet C being produced, and that can be very dangerous for the skins and tissues if anyone is coming in contact with UVC for a long duration. Then there is UVB. In UVB, we have 280 to up to 315 nanometers. Now, this is slightly more in wavelength. That's why slightly less harmful. And again, almost up to 95% of UVB is completely absorbed by the ozone layer. Just about 5% is able to come through, and it is able to pass through the ozone layer and reaches the surface of the earth, and it can cause sunburn even in shorter duration. So it can harm the top layer of the skin within 15 minutes of sun exposure as well, and that's why it can cause sunburns. The top layer of the skin can be affected. Then there is UVA, longest wavelength, 315 to 380 nanometers. Now, the least harmful out of the three types of ultraviolet, but penetration wise, it will be easily able to reach the surface. almost 95% of UVA is able to penetrate through the ozone layer and reaches the surface of the earth, and they can go deep into the tissues also, and that's why they can actually lead to some of the skin diseases. And they also have been linked to cancer, that there are chances that UVA specifically, long exposures, very long exposures, very frequent exposures to ultraviolet A can actually lead to skin cancer as well in certain cases. So that's why they actually can lead to spots on the skin or wrinkles on the skin. All these things can be also caused by UVA. Then there are X-rays. So with X-rays, there are two types of X-rays. We have soft X-rays and we have hard X-rays. So they have the range between 3 into 10 to the power of 16 to 10 to the power of 18 hertz, and wavelength between 10 nanometers to up to 100 picometers. 10 nanometers to 100 picometers. And they X-rays, we know that they are useful in medical purposes, in some industrial purposes also X-rays are used. So largely these are soft X-rays. And then there are hard X-rays. Now hard X-rays, basically they occupy the same region as the gamma rays. They have the same frequency and wavelength as gamma rays. So gamma rays have frequencies that are greater than 10 to the power of 18 hertz and less than, wavelength of less than 100 picometers. Now, in case of gamma radiations, we know that they can cause damage to the living tissues. They can actually be used for killing cancer cells, and they can be very dangerous. Even very short exposures to gamma rays can simply burn through the skin and tissues. So they are very, very dangerous, even in very short span of time, in smaller quantity as well, because they possess a lot of energy. Now, just remember that when it comes to communication, the first four that we discussed, they can be used in communication, in wireless communication, in one way or the other. So, radio waves, microwaves, infrared waves, and the visible waves. These are the ones which can be used for communication, for wireless communication. Ultraviolet, X-rays, and gamma rays. These three, they cannot be used for communication because they have very high energy, and using them for communication first will be harmful, and secondly they would not be cost effective at all. You would be wasting a lot of energy, you'll be using up a lot of energy, hence you'll be wasting a lot of money in making that work. So that's why not practical and also very harmful for us. So that's why ultraviolet, X-rays, and gamma rays, these three, they cannot be used for communication, and the other four, they can be used for wireless communication. So before we start wireless communication, any questions if you have from whatever we have discussed until now? Low frequency equal to long wavelength. That's true. That's correct. How the radiation waves are harming us? See, not radiation. I mean, we are talking about gamma. Gamma rays have very high energy. So because they have very high energy, they can just enter your body. They can enter through your body. They can burn these skins and tissues. They'll just burn it because they have very high energy. So that is why we are saying that they are harmful. What's the best time for sunbath to prevent skin damage? Mornings or evenings? Mornings rather, because that is where the intensity of sunlight is lesser, and that's why the the UV exposure is little less. Did we intentionally send BrahMos in Pakistan by changing its path continuously? We don't know, and we would never know. What kind of questions from waves topics? So largely it can be about frequencies or wavelengths, or in some cases applications. We'll discuss about some of these. You'll find where they are useful. There are questions that we have in the upcoming slides. You'll find understand that there. Specifically, at what time these waves come? What waves are you speaking of? Please let me know. But every wave is always available. There is nothing, there is no time limit to it. It depends on the source. If the source is there, the wave is there. If hard X-rays have the same wavelength as gamma rays, how are they different? They're different because gamma rays, where is the source of gamma rays? Inside the nucleus, if you remember, it is inside the nucleus. Whereas X-rays, they originate from the electrons. So electrons are the origin of X-rays. Nucleus is the origin of gamma rays. So that is why their properties are different, because of the configuration from where they originate. Do radio waves also affect our body and mind? There is no concrete study to prove that. There are some studies which have said that prolonged exposure can be bad, but not a lot of studies have been able to conclude that with a lot of evidence. Do we need to remember the wavelength and frequency figures of different waves? Uh, Yes, more or less you do. You, even if you don't know exactly, at least know the order. Order is very, very important. But the figures in certain cases are important. There have been questions in the past where they have asked questions related to those figures, and that's why the figures can be important, because they've done that in the past. Where do we use infrared for communication? Actually seen everywhere, only radio waves are used. Infrared is used largely in cases where there are frequency jammers, where radio waves will be jammed and we need short term, short range communication. Infrared can be useful there. What is the meaning of 480 nm to 380 in layman? So 480 nm means 480 nanometers. 480 nanometers. We discussed nanometers yesterday, meaning that we are saying 480 into 10 to the power of minus 9 meters. This is what it means by 480 nanometers being wavelength, meaning that the distance between two similar points on the wave is just 480 into 10 to the power of minus 9, a very small distance. My father does welding and he feels pain in his eyes. It is because of the energy that is released or smoke. It is largely because of the energy. Largely because of the energy that is released in that. The smoke has not a lot of significance from health perspective, but the energy being released by welding is something that is dangerous. How birds are dying if radio waves are harmful? No, see, again, I'm saying this. See, there are a couple of reports. The problem is that we concentrate every time there is one negative report. So we focus everything on that one negative report. For every one negative report that has been published against radio waves or mobile radio waves, there are 99 other reports that have not been able to conclude anything. So until the time they don't conclude anything, it's not a sensational news for us, and that's why we don't follow that. But as soon as one negative news comes, we start following that itself. So that's why uh, uh, that's why I'm saying that there is no conclusive study to say that whether they are harmful or not. In one movie, infrared rays used to hide from camera. Yeah, infrared actually, I mean, cameras cannot catch infrared, so maybe that was shown there. At last day of the class, can you list the topics for prelims and mains? See, the topics that I'm teaching in the class, nobody can guarantee that only these are the topics from where questions can come. If I give you a list of topics, I still cannot guarantee that the questions will come from there. even it is current affairs. In current affairs also, nothing can be guaranteed. So one should not wait for this kind of a topic list, that these are the areas from where questions will come. Nobody can predict that. If I knew that these are the 15 questions of science and technology, I would just teach you those 15 questions and not all these entire chapters. So please don't wait for that. And really, I mean, I will be confused even if I had to give you topics, that okay, these are the topics or these are the important topics. I'll be confused, because sharing that topic list will be very very difficult, because we have seen how many questions in how many ways can come in the examination. So that's why it's very very difficult to predict that these are the topics. So unfortunately, that's very difficult to do. Can we say frequency inversely proportional to wavelength? Yes, I told you that it is inversely proportional. Is sunscreen a must? Depends on how much exposure to sun you have. If it's just, let's say, 15 minutes to half an hour or 1 hour exposure every day, nothing happens from that. And that is even good, because sunlight is required for vitamin D synthesis in our body. Only if there is prolonged exposure to sun every day, then in that case somebody would need sunscreens. And in the sunscreens also, if you see, they write that they protect against UVA and UVB, and they would use the term called as SPF. So there is SPF 20 or SPF 40, SPF 50 and 60 and so on. So SPF stands for sun protection factor, that what is the intensity against which they can protect you. That somebody, for example, living in the mountainous areas, for example, let's say if you are living in the higher altitudes of Uttarakhand, Himachal, Leh, Ladakh or Jammu Kashmir, or in the northeastern states, then in that case, I would say that you need sunscreen which has a higher protection factor. And if you're living in the plains, if you're living in low lying areas, then the SPF requirements will be lesser. Similarly, SPF requirements in summer will be higher than the SPF requirements in winter. So it all depends on the geography of the region. It means X-rays are harmful. Yes, X-rays are harmful. Again, that's why you'll see that there are shields which are put wherever there are X-ray rooms in any hospital. They would have it in the basement or somewhere at the corner, and there will be a lot of ways in which they would try to ensure that there is some kind of uh, protection, some kind of shield, so that X-rays do not go out of that room and they can remain confined in that room itself. Otherwise, a lot of people who are working in the hospital, they would be exposed to these X-rays. In case of, let's say, cancer hospitals, you'll see that cancer hospitals are not even allowed to be constructed in areas which are residential. Hospitals might be constructed, but cancer hospitals will not be constructed in these areas, because they would be using a lot more of gamma rays, and that's why it can be harmful for the areas or for the people who are living in those areas. Why birds are dying because of radio waves as shown in the movie? Was shown in the movie. Please don't compare it to real life, please. The entire villain was made out of phones and everything. So that's not possible. Films can show that. Reality is different. Is lights also harmful? No, not at all. Wavelengths are longer, so they are not harmful. Do our eyes start feeling pain due to emission of light from screens during operating the mobile? Yeah, because you basically are exposing your eyes to the blue part of the light, which has shorter wavelength, and that's why it can irritate the eyes. And that's why you'll see that there are protection filters, and there is you have specs that can help you against it. Or even the mobile phones today, they have the filter for the blue light, especially. So you told infrared used for signal. No, not used for signal jammer. Used when signals are jammed. When radio signals are jammed. So many of you are mentioning about the movies, that movies may, they showed this and they showed that. Let them show whatever they are showing. These are science fiction movies. They do not really mean anything. They have imagined it to be so. That's not the reality. It's not a documentary, it's a film. Please remember it. Kindly start a class for past 1 year current affairs in the field of economy, science, technology, environment. We actually are planning that, and as soon as we are ready with the curriculum, we'll also announce it. SPF 2030, what does it mean? It means that they have, basically they would be able to protect you from harmful rays, and especially they'll be able to protect you against UVB. The higher the sun protection factor, it means that they'll be also be able to protect against UVB more. Otherwise, sun SPF factor up to 20, etc., or up to 30 will protect you more against UVA. So that's why, let's say somebody who's going on mountains or going on beaches, they would need higher SPF in the sunscreens, so that they can be saved against sunburns. But if in daily use, SPF 50 60s are not really required. So I'm giving you a lot of cosmetic gan here. In reality also, we can't see a lot of birds that we have seen in the childhood. It's not related to radio waves, please understand this. It's related to, a lot is also related to the environment. I'll tell you one example. For example, why sparrows have disappeared. Sparrows have disappeared because the way we make our houses have changed. We used to have a lot of houses which would have a lot of areas where the birds can have or find their nesting places. You would have windows where nesting places were available for them. But now we started having flat vertical walls and spaces, and that has led to a lot less nesting spaces in the urban area, so they had to move away from these urban areas. So there are other reasons for that. So please don't think that it is related to radio waves at all. Why house sparrows become invisible? See, I just explained this, that there are other reasons for that. Infrastructure is largely the reason for it. One doctor told lens are of no use for mobile phone screen light. That's actually true. I mean, lot of it is also marketing, that they have a UV protection layer and all that. Doesn't really make a lot of difference if you knew the reality. Just that it's a way for them to charge you higher than usual. You told science fiction, today science fiction is tomorrow reality. That's true, but you cannot change science. You, some, let's say if radio waves are not harmful, they're not harmful. You cannot change that reality. So it's not science fiction, it's reality. You cannot change reality. Newton's laws of motion are Newton's laws of motion, today or tomorrow. So these things are realities. Concepts cannot change. Concepts cannot change. New technologies can come up. So that's different. So you have to understand the difference between the basic concepts of science versus what is being applied and how it is being applied. Why don't we feel anything when x-rays happen? So that short exposure will do nothing. If you were exposed longer, then it will start showing problems. So that exposure is for like seconds, like 5 seconds, 10 seconds, that's it. So that will not cause an issue. But if you were exposed to it for 10 minutes, for 15 minutes, for 20 minutes, then you'll see the difference. But please don't do that. Every education company, imagine, knows some student's name that can clear the examination. Just like schooling. Not really. I mean, we have seen a lot of surprises of people who we thought would do well, have not done well. People who we had no expectations from have done exceptionally well. And we have, I mean, I have taught a student who got rank 16 all India, and in the classroom I could have never told that she would be a student to get rank 16 all India, and also got the highest marks in the mains examination in the entire country. So in the classroom nobody would have predicted that. So that's why it is not something that we can ever predict. It depends on student, and on the day of the examination, if the things that you have studied, you are able to do that well, you are able to apply that well, it will work. The white light patch below the PPT of our class is causing eye strain. I'm not sure what that is. I'll have to check that in a real video so that we can solve that problem. Lenses and blue filter glasses are really effective or not? They are partially effective. It's not that they are completely ineffective. They are partially effective, but not as much as it is portrayed. Yashika, you are male. If it was about a doubt, I must have given it to somebody. I mean, I must have forwarded it to the people required. I'll see it again. Right. So let's move on. The next topic is wireless communication. Now, in case of wireless communication, there are few types of wireless communication that are very, very important. So what are these wireless communication? Let's try to understand that first. First is Bluetooth. So Bluetooth is a short range communication where the range is generally less than 10 meters. So range is less than 10 meters. All right. So very low range, right? 10 meters of range. And operational frequency is 2.4 gigahertz, meaning that it functions at 2.4 gigahertz frequency. Now, when it comes to the devices connected in Bluetooth network, they use ultra high frequency radio waves. Ultra high frequency. So, very high frequency means what? Shorter wavelength. Shorter wavelength means what? Lower distance, less distance coverage. That's why their range is less. That they have a range of only 10 meters. Now they can travel between walls. You can, let's say for example, if you have two mobile phone devices in two different rooms, can they communicate? Can you transfer a file from this room to that room? If the range is 10 meters between this room and that room, you can. Even if there is a wall in between, even then you can. So that's why it can penetrate through the walls, it can transmit through the walls, but the range will be short. The range will be up to 10 meters only. And it operates on a concept called as frequency hopping spread spectrum. So frequency hopping spread spectrum basically adds to the security. It enhances security of Bluetooth. All right. It enhances the security of Bluetooth connections. Similarly, there is near field communication. Now, in case of near field communication, the range is very less. The range is less than 10 centimeters. Less than 10 centimeters, meaning that they have to be this close. In most of the cases, the range will be just in the range of not more than 2 to 3 centimeters only. All right. So range is very less. The range is very less. All right. So the devices that are communicating via NFC, they have to be virtually touching each other, and then only this transmission is possible. The operating frequency is 13.56 megahertz, and this is where we see that it can act as a reader and a tag. So there are various ways in which we use it. For example, let's say uh, a lot of contactless cards, for example a metro card, where you just swipe the card or you just touch the card and you can get through. So that is where NFC is used. In many of the offices there are ID cards that can be used in on the gates so that you can enter the offices. So that is also NFC. So there are a lot of ways in which NFC is used. Even cards that you can just tap on the payment machine and it takes the payment, that also is where we can make the use of NFC. So in payments also it can be made, and that is where we can add an extra layer of security. We can actually encrypt these communications as well while using it. So that is how NFC becomes crucial. Read this question. This has been asked on NFC. Please read this question. I'm launching the poll for you. All right. Hmm. So 51% of you have marked C, which is the correct answer. I needed more of you to mark the correct answer. With reference to real near field communication technology, which of the following statements is or are correct? First is, it is a contactless communication. This is fine because it is wireless. That uses electromagnetic radio fields. This is also correct. It uses radio waves. So first statement is correct. Second is, NFC is designed for use by devices which can be even at a distance of even a meter. How is it this correct? I just told you they have to be virtually touching each other. How is it possible that even a meter can work? No, maximum of 10 centimeters, largely just 2 or 3 centimeters. What are the examples? The cards that you're using at metro, the biometric devices, or maybe even the cards that you're using in schools, colleges, offices, your payment cards, your debit or credit cards. These are the examples where NFC is being used. So can you use it from even a meter? You cannot. So that's why this is wrong. It was an easy answer to mark. NFC can use encryption when sending sensitive information. This is correct. We discussed that while sending payments, we use encryption as well. So that's why this is correct. So 1 and 3. So contactless communication using radio fields, and again, it is it can use encryption as well. Then we have radio frequency identification, or RFID. Now, in case of RFID, the way RFID works is pretty similar to how NFC works, but with certain improvements. That first, the range. The range is very large compared to NFC. The range can be up to 100 meters. All right, so even better than Bluetooth in that sense. And then here, they can even travel even if there are obstacles, even if there are obstacles like walls, etc. Even then it can travel. So that's why we say that no line of sight is required in terms of its working, and that's why it becomes very crucial, and it can act very fast. So what happens is that many a times these RFIDs, they are used in libraries, they are used in libraries they are used in warehouses. Now, the reason why they are used in libraries and warehouses is the fact that here what you can do is that if you have an RFID machine, you can simply tag throughout. You can just get the information for everything that is kept in the entire library. Suppose that instead of RFID, if you were using NFC, then what happens? Then you have to go to each and every book, and then you have to take the information from there. You have to scan each and every book. Whereas when you are using RFID, you can just stand at a place and you can just start scanning altogether very easily. So that's why it becomes easier to use in that sense. And there is one very, very important example or of RFID that is being used in India. Can you tell me where are we using this RFID? Yes, in the fast tag, in the toll plazas. So fast tag is where we are making the use of RFID in India. So overall, they simply would work like this, that you have an RFID reader that will be installed at the toll plazas, and they are connected to an antenna, and they would receive the information through an RFID tag. And your vehicle, your car would have the RFID tag. So then the RFID tag will be read. All right, the RFID tag will be read with the help of the reader, and reader will pass on the information to the database, and the payment will be taken like that. So in this manner, we see that RFIDs can actually work in this regard. Then there is Wi-Fi. Now Wi-Fi stands for wireless fidelity. Wireless fidelity. Now what do we mean by wireless fidelity? Now in this context, operating frequency of Wi-Fi can be 2.4 or 5.2 gigahertz. The range can be 45 to 90 meters depending on what kind of Wi-Fi it is. Now overall, there are different types of wireless technology. The first wireless technology that we started using was 802.11a, and then 802.11b, G, and N came. Now, by the time 802.11n came, this is where Wi Fi had become very popular, and now it was being used by a lot of people across. So, we had started using this Wi Fi 4, and so that's why it was renamed as Wi Fi 4. 802.11n was renamed as Wi-Fi 4 because now it had become popular. It was being used by people all across. So that nomenclature was made easier for everyone to recognize this Wi-Fi. So Wi-Fi 4, and that's why these were named as 3, 2, and 1. These subsequently were named as Wi-Fi 3, 2, and 1. And then after that came Wi-Fi 5 with much better connection and better capabilities to uh, connect to a lot of devices. And today you can say largely we are using Wi-Fi 5. In most of the cases that we are using in India, we are using Wi-Fi 5. But now Wi-Fi 6 has started entering the market. Wi-Fi 6, since last year, almost you can say second half of last year, now we see that Wi-Fi 6 also has started entering the market. I don't know whether you have noticed or not. There are some Wi-Fi connections, if you connect to, something like this will be visible. Is it visible on the screen that there is a small 6 written on the top of the Wi-Fi network? So this 6 that you see, this basically says that I was connected to Wi-Fi 6. So as soon as I saw 6 written there, I was on some network, I don't remember. I quickly took that screenshot so that I could use it in the class. So Wi-Fi 6 now is available in India also since last September, October. There have been some uh, network providers who are now providing Wi-Fi 6. Now let's understand what is Wi-Fi 6 and how is it different, how is it better than whatever we have been using until now. So when it comes to Wi-Fi 6, there are two key technologies that are being used in Wi-Fi 6. One called as OFDMA and the other one called as MUMIMO. OFDMA stands for Orthogonal Frequency Division Multiple Access, and MUMIMO stands for Multiple User Multi Input Multi Output. So this stands for orthogonal orthogonal frequency division orthogonal frequency division multiple access. This is what OFDMA is, and MUMIMO stands for multiple user multi input multi output. So this is what these two stands for: orthogonal frequency division multiple access and multiple user multi input multi output. Now understand what exactly changes in terms of this Wi-Fi technology or Wi-Fi 6. Now why are these two technologies important and where do they contribute? Now overall Wi-Fi 6 is there are two main features of Wi-Fi 6. One, that it is way faster than Wi-Fi 5. It can deliver way higher speeds than Wi-Fi 5. And second, it has very low latency. Latency meaning delay in the network, lag in the network is very, very less with Wi-Fi 6. And also it can connect to higher number of devices. So for example, Wi-Fi 5 can connect to, let's say, 5 to 6 devices without any problems. But as you start increasing the number of devices, you'll see that there will be a drop in the speed. With Wi-Fi 6, you might be able to connect to more than 30 devices without losing any speed. So way faster in terms of speed, can connect to way more number of devices at the same time without losing speed, and the lag in the network or the latency in the network is very low. So these are some of the important features of Wi-Fi 6. So these features, so becomes faster, less latency, better security, improved battery life, and I'll add, as I told you, more number of more number of simultaneous devices can connect. All right. So more number of simultaneous device connections are possible. Now, when it comes to this particular scenario of Wi-Fi 6, so there are these advantages. So it is faster, meaning that the internet speed that you get in terms of how many Gbps of speed you can get, that will be faster. That is what we mean by being faster. And then we are seeing lesser latency. So latency, as I told you, this is nothing but the lag in the network or the delay that we have in the network. Now, what do we mean by this lag or delay? Many a times, okay, anyone who knows where this is from, do you know where this screenshot has been taken from? Yes, many of you know. It has been taken from BGMI, as it is called now, or PUBG as it was called then. Now, if you have played, is there anyone who has played? Yes, a lot of you have. I hope that you don't play anymore. I just hope that you don't play anymore. So because it wastes time in no time, that your 1 hour, 2 hours, 3 hours will go without you realizing that you wasted your time. So so even if you had the habit, I hope that you don't have the habit anymore. Now, there is this number that is displayed for those of you who have played, and for the rest of you, I'll discuss another example. For those of you who have played, you see that there is a number that is displayed on the left hand side corner, right at the bottom. And if that number is a two-digit number like 20s, 30s, 60s, 80s, then in that case, it means that it is working well. Your network is connected well, and you are very well connected in that particular game, and that is in milliseconds. That number is in milliseconds. So if the number is 60, it means that the lag is of 60 milliseconds. But as that number starts rising, if the number is 150, if the number goes beyond 200, 300, 400, then that gives you an escape, that you can tell others that I was not able to play well because my ping rate was high, right? We say that my ping rate was high. So that ping rate is nothing but the lag in the network. So if that number is high, it that is where you can say that when you did not play well, it was not because of the fact that you don't know how to play well. It was because of the fact that your device was not good enough. So so that is what ping rate. When we talk about these ping rates, and when we talk about this uh, these kind of delays or latencies, this is what latency means. Now, this latency you might have observed in many ways. Maybe sometimes even in these lectures, you might see that the audio and video may not be synced properly. That maybe audio is coming first and then the video, or there is some lag, that my video comes and maybe the slide does not come on time, or what I write does not come on time, or maybe my lips are moving but the voice is coming 2 seconds late. So all these things can happen with a video. So if that is happening, it means that there is some kind of lag somewhere in the network. Either it is with your internet connection, maybe it is with your device, that the device is not supporting higher rates of uh, the data that you're getting. So maybe that's the problem, maybe the network is the problem, or maybe at my end there is some problem with the network. So there is some kind of problem somewhere in the network that is causing a delay. So that delay, because everything that is displayed, the video that you see, the audio that you hear, the ppts that you see, everything will be transmitted as waveforms, and all these waveforms are synced together, they are synchronized, and then they are transmitted. But due to some kind of issue somewhere in the network, either with the device or with the network, maybe network of the transmitter, maybe network of the receiver, there can be n number of factors that can lead to this kind of a delay, and that delay is called as latency. Many times you'll see that if you are seeing a news in a news channel and there is a ground reporting that is happening, so whatever the ground report says, the people who are sitting in the studio, they take 3 more seconds to hear everything. You might have heard it, but they are still hearing it because there is a lag in their network. So that's why all these things actually are nothing but lag in the network called as latency. And in terms of Wi-Fi 6, we are drastically trying to reduce that latency. Right, so that is how we see many a times, even in the let's say if there are many devices which are connected to one single server, then also there can be delays in the office networks. Many a times these kind of delays can come because there are a lot of devices that are connected, and that is leading to some kind of delay in that entire network. So that's why that is what we call as latency, the lag or delay in any given network for many different reasons. So there are all these advantages that we get out of Wi-Fi 6, and there are these two important concepts that are giving us these advantages. So first is orthogonal frequency division multiple access, OFDMA, that improves the efficiency and reduces the latency. And then there is MU-MI-MO that increases the capacity of the network and results in higher speed per user. So that's why these two concepts, they become very very crucial, because they are the ones that are leading to these two things. So OFDMA will reduce the latency, and MU-MI-MO will increase the capacity, and hence they would improve the speed, they would improve the high, they would provide you higher speed per user. So these are the things that we basically see with regard to Wi-Fi 6 and where Wi-Fi 6 is able to help today. Please read this question: the difference between Bluetooth and Wi-Fi devices. Please read the question. I'm launching the poll for you. Hmm. All right, so 24% of you have marked A, which actually is the correct answer. Let me discuss this with you. What is the difference between Bluetooth and Wi-Fi devices? See, whoever marked A or D, I can understand. C should not have been marked. Let me discuss this. First statement, first option says Bluetooth uses 2.4 gigahertz radio frequency band. This is correct. Wi-Fi can use 2.4 or 5. This is also correct. We discussed 5.2 to be exact, but 5 is also fine. So this is correct. Statement B, Bluetooth is used for wireless local area network only. whereas Wi-Fi is used for wireless wide area networks only. We have two onlys. So first you should have read it thoroughly. Secondly, when we talk about these networks, when we say wide area network, there are different types of networks. So for example, we have personal area networks. So personal area network is where we are talking about a network maybe just within a room. So network within a room. And then comes local area network. Now in case of local area network, it could be in one or maybe couple of buildings, or even maybe just an entire floor. So then in that case it is LAN, local area network. Now where would Bluetooth work? In personal area network, right? Largely in personal area network. So should not work in local area network, and that too only in local area network. Wi-Fi used for wireless wide area network. So after that comes wide area network. Now wide area network basically can cover a locality or cover a colony. All right. So then the wireless wide area network. So now Wi-Fi will be where? Largely in personal area network and local area network, correct? Either within a room or maybe within a building. That is where Wi-Fi would function. So that's why wide area networks, no. After this comes another one, which is metropolitan area network, which can cover the entire city. So that's why this is wrong. Third, when information is transmitted between two devices using Bluetooth technology, the devices have to be in the line of sight of each other. Line of sight, we discussed that in case of NFC, that line of sight means what? That there should not be any obstacle. But are we saying that Bluetooth, if there is obstacle, Bluetooth cannot work? Bluetooth can work. You just try it at your home. Bluetooth can work even if you are communicating within or maybe two sides of the wall. As long as the distance is not more than, let's say, 10 meters, Bluetooth would work. So it's that's why Bluetooth will work even if there is no line of sight. So that's why this is wrong. Wi-Fi technology is used when devices need not be in the line of sight. So this is correct. But in case of Bluetooth also, they need not be in the line of sight. So C is wrong, and because B is wrong, D is also wrong. So C, that's why I'm saying that C should not have been marked, because C is something that you see practically. You can see that practically also, that Bluetooth can work in these cases. And we had discussed about this as well. Now coming to Li-Fi. Now, Li-Fi stands for light fidelity. Light fidelity meaning that this is where we are making the use of light. We are making the use of light waves for wireless communication. So that's why transmits data via light. Largely, we can make the use of LEDs. Largely, we can make the use of LEDs. It becomes very fast, almost 100 times faster than Wi-Fi, speed up to 224 Gbps, and of course runs on 380 to 780 nanometers of wavelength, because light waves it is running on. Light Li-Fi signals cannot pass through walls. So this is correct in the case of Li-Fi, but not in the case of Bluetooth, because light waves are being used. Can light pass through walls? No. Otherwise, you would have used the same light bulb for the entire home. But unfortunately, for every room, you have a different light bulb, correct? Because light cannot pass through walls. So light cannot pass through walls, meaning that Wi-Fi communication cannot also happen through walls, because light waves cannot pass. So how would the communications happen? It can't. So that's why it cannot pass through walls, and also seen to be more secured as compared to Wi-Fi. Now the question is, where would we use Li-Fi? When it comes to Li-Fi, in terms of Li-Fi, it would be used largely again in the cases where using radio waves is not possible. Wherever using radio waves is not possible, we might make the use of Li-Fi in these cases. Now, consider an airplane. In the airplane, as you go, you would be asked to either switch off the phone, or maybe put the phone in the flight mode or airplane mode. So by putting the phone on airplane mode or flight mode, etc., we start blocking the radio communication. we block the radio communication of that mobile phone. Why do we do that? Because the pilots are communicating via radio waves. So that's why, to avoid any kind of interference in their communication, we are taking this precaution. This is where Li-Fi can be used. That within a flight, Li-Fi can be used to provide you internet. It can be used to provide you internet without making the use of radio waves. So because radio waves already have been asked to be kept on, or to already have been blocked, and that's why in this particular regard we see that Li-Fi can be used. So that's why Li-Fi is used to avoid interference, used to avoid interference mainly with to use to avoid interference mainly with radio waves. So that's why in the flight we would be asked to keep the phones on flight mode so that radio communication can be blocked, and that is where we'll see that Li-Fi actually can be used in a lot of cases. Surprisingly, there have been two questions in the past 6-7 years that have been asked related to Li-Fi. Read this question. It's an easy question to answer. Please mark your answers. Wonderful. 80% of you have got me the correct answer. So the question says, with reference to Li-Fi recently in the news, which of the following statements is or are correct? First, it uses light as the medium. That is correct. For high speed data transmission, this is also correct. Now notice this question. There are two parts to both the statements. Light being used, this is also correct. High speed data transmission, this is also correct. Wireless technology, this is also correct. Several times faster than Wi-Fi, this is also correct. So that's why both these statements are correct. So correct answer will be both 1 and 2. Read this question. I'll launch the poll for you. Please mark your answers. So I understand why many of you have marked A. Let me discuss this with you. With reference to visible light communication, which of the following statements are correct? Now, visible light communication, where we are making the use of visible light, so you can say that Li-Fi is an example of visible light communication. All right, it is a kind of visible light communication. First is, it uses electromagnetic spectrum wavelengths 375 to 780 nanometers. Now, this is correct. We had discussed precisely 380 to 780, but that's okay. these kind of variations you might see. Sometimes 350, sometimes 400, sometimes instead of 780 they would write 800 or 750 and so on. So that happens. So that is okay. And then VLC is known as long range optical wireless communication. Now this is not long range. We discussed that it is very short range, correct? It's very short range, just within a room. You'll be able to use it just within a room because light cannot travel beyond the room. So that's why 2 is wrong. Third statement is VLC can transmit large amounts of data faster than Bluetooth. Obviously faster than Bluetooth. It is way faster than Wi-Fi, 100 times faster than Wi-Fi. So obviously way faster than Bluetooth. So C is also correct. VLC has no electromagnetic interference. Now this is where I don't completely agree with this statement, unfortunately. The best possible answer should have been 1 and 3. Best possible answer should have been 1 and 3. But in the absence of any option that says 1 and 3, because 2 definitely is wrong. 2 is wrong for sure. That's why if we had to choose the most appropriate answer, then I would say that it is 1, 3, and 4, because 2 definitely is wrong. But the problem with statement number 4 is that it says no electromagnetic interference. Now, what we discussed is that it is used to avoid electromagnetic interference with radio waves. So, saying that without taking the reference of radio waves or other radiations, just directly we saying that it has no electromagnetic interference would be wrong, because it can have electromagnetic interference if there were two light sources or there were two Li-Fi sources kept in the same room. Then there are chances that electromagnetic interference can happen between them, but we are using them only or largely in the areas where we are trying to avoid that interference. So that's why it's an English problem, I think, with this statement. Otherwise, in the strictest sense, I would have said that the correct answer should have been 1 and 3 only. In the absence of 1 and 3 only, the most appropriate answer and also the official answer is 1, 3, and 4. But this would have been the most appropriate, or let's say most correct answer, or perfectly correct. Let me write perfectly correct answer. This would have been perfectly correct answer, but this is the official and the most appropriate answer, 1, 3, and 4. Now coming to our next discussion, but do we have time? Yeah. So this topic we can do. So we are talking about mobile phone networks. Actually, this is a longer topic. Let us do this tomorrow. We'll discuss about 5G, we'll discuss about Internet of Things, and we'll discuss about supercomputers and quantum computers. These are the topics that we are left with. So let's do these topics tomorrow. Or let me do something. I mean, because we have some time, instead of reading about 5G, because this is a longer topic, let's discuss Internet of Things, a smaller topic. It's just a 5-minute topic. So let this be the last topic for today. Internet of Things. Now, what do we mean by Internet of Things? Let's try to understand that. So, there is a question, a very important and very good question that was asked by UPSC. This was asked in your 2017 paper, if I'm not wrong. Just read this question. Just read this question, please. And please let me know when you are done. Please let me know when you have read this question completely. To ask you what the answer is, I'm not. Hmm. So some of you are done. Do I really need to launch a poll for this? Let me do an experiment. I'll give you just 10 seconds. Okay, let me give you 15 seconds. Mark your answers. I just want to see if you don't know what the answer should be. I know I've not discussed this. So, okay, so 75% of you have marked B, Internet of Things. I also would want to understand why others do not think that it is Internet of Things. We are discussing the topic Internet of Things. I gave you a question. Why would I give you a question based on something else? All right. So this question basically talks about a luxurious life, probably a life that maybe some of you imagine, that what if this was possible? And this question was asked in your prelims paper. When the alarm of your smartphone rings in the morning, you wake up and tap it to stop the alarm, which causes your geyser to be switched on automatically. The smart mirror in your bathroom shows the day's weather and also indicates the level of water in your overhead tank. After you take some groceries from your refrigerator for making breakfast, it recognizes the shortage of stock in it and places an order for the supply of fresh grocery items. When you step out of your house and lock the door, all lights, fans, geysers, and AC machines get switched off automatically. On your way to the office, your car warns you about traffic congestion ahead and suggests an alternative route. And if you are late for a meeting, it sends a message to your office accordingly. I have to call from a traffic light to the coordinators that I'm stuck in traffic. So anyway, so so this is basically what we are talking about. And here, as you can see, that there are all these devices that are actually connected. These are all electronic devices that are connected via a network and they can communicate with one another. This is the concept of Internet of Things, where we are talking about a bunch of connected systems, a bunch of connected uh, systems or electronic devices that can work uh, in that network on their own. So, did you understand now what is Internet of Things? Can we stop the class here and move on? So, Internet of Things. So, what we mean by Internet of Things, the term basically was coined in back in 1999, and this is a term used for interconnection of things. Now, things here basically would mean electronic devices. So, we are talking about a connection of electronic devices, a bunch of electronic devices that are connected together. Now, overall, that's why a lot of digital devices and appliances, they can all be connected together. But it's not only about a luxurious life. The kind of question that has been shown there, there are a lot of ways in which we can see the applications of Internet of Things. So, for example, health monitoring in smart city projects that we are building. Today, we see that even in case of traffic management, we are making the use of Internet of Things. We want to make the use of Internet of Things. Similarly, for energy optimization, we want to use Internet of Things. We see that we can make the use of Internet of Things in factories, in hospitality, tourism, even in farming, in health monitoring. So there are a lot of ways in which we have found that there are various sectors where there are certain services, there are certain things that can be automated with the help of Internet of Things. And until now, although as a concept, Internet of Things has been here for a very long time, because robotics has been there, and robots also, we have been trying that they should be able to work on their own. But now that we have much better internet connections, we have much better devices that can communicate with one another without any latency, with very high speeds. Now we see that we are in a situation where Internet of Things in the past couple of years has started to actually become a reality. With, let's say, even the advent of things like 5G and Wi-Fi 6, the things become even more easier, because now number of devices can be connected together without losing the speed. So that's why all these things become very crucial in making Internet of Things work. And that is where we see that today, in the last couple of years, now we are entering an era where Internet of Things can become a reality. So the government of India has decided to embrace the technology in a big way, and we have seen that we have pledged that we'll set up an IoT industry worth $15 billion. Overall, in the initial phase, a grant of rupees 18 crores is also being given. And for the smaller enterprises, for the MSME sectors largely, we see that grant of rupees up to rupees 6 lakhs per enterprise per annum is being also given. So we see that there are a lot of financial help that is being given by the government of India so that they can start promoting Internet of Things in various different sectors. And in the education also, that's why we see that there is a lot of introduction wherein BTech courses, MTech courses, PhD courses, there are students who are taking interest in Internet of Things. Then it also becoming a part of Digital India mission, also becoming a part of National Digital Communications Policy. We see that these are certain areas which also indicate that how government of India also wants to develop its capacity with Internet of Things. And the first case of Internet of Things being used by the government has been the airport at Sikkim, which is near Gantok. Now, in this airport, we have an IoT based system that has been installed there, which actually works as an early warning system. Early warning system against earthquakes or seismic activities. So it can predict and it can do an early warning. It can make an early warning for against any seismic activities, and that's why it can predict earthquakes. So all these have been done with the help of Internet of Things. So that's why we see that today Internet of Things has started to grow, and we have found various different ways in which Internet of Things can work. Although it does come with certain limitations as of today, that initial setup cost is going to be high because you need a lot of devices that have to be connected together. Then there are connectivity and security issues that can happen. It can lead to a lot of job losses because it is basically about automation. So automation would mean that a lot of things that are being done manually that can be lost to these machines that can interact and they can do the work on themselves. So that is where it can be very dangerous as well. Similarly, there are concerns of digital surveillance. The question that we saw, the example that we saw is where, let's say, there are, I mean, today also we see that there are all these devices which are gathering your information. You know about that, that a lot of these devices are gathering your information without your permission in many of the cases. And even if you have granted the permission, you never know that you granted the permission. So that's why, unfortunately, this all is called as digital surveillance, where the companies probably they are following your activities, marking your activities so that they can give you maybe better experience, but all that is happening without your consent many a times. So that's why it all leads to digital surveillance, and they would start try and make things and products in a manner that people are always engaged with their products, they're always engaged with their softwares, etc. So they would want to improve upon that. So that's why digital surveillance becomes a way for them to do that, to understand where the pain points are so that they can improve upon that and make more money out of it. So that's why this all can happen. Similarly, reliability of sensors is also important. In many of the cases, we know that because they have to interact with each other, their sensors have to be very strong. Their sensors have to be very good so that they can communicate with each other very easily. So that also is one thing. Then there is an issue that it can also consume a lot of power, because we are saying that a set of devices will always be connected and they'll be consuming power all the time. So that's why the overall electricity consumption will rise because of Internet of Things. So that also needs to be understood. Then lack of international standardization, and this is something that can lead to compatibility issues. That this is where we see that now, uh, because of lack of standardization, what may happen is that, let's say, there is a device, there are 5 devices that you're using as a part of your IoT system. One device that was manufactured in China, one device that was manufactured in US, one manufactured in Korea, one manufactured somewhere in Germany, and one manufactured in India. And all these may have followed their own standards in their countries. So that's why when they are all being used together, they might not function very well, they may not be able to interact very well. So that also lies, that also is one of the issues. And then lack of skilled resources to maintain and run such systems. Now this is also very important because we see that this is a very new sector. Only in the last 4 5 years have we seen that a lot of developments have happened in the systems related to Internet of Things. So that's why we are still not in an era where we have a lot of manpower, a lot of human resource available which can run these systems, which can design these systems. So that's why these kind of limitations, they still remain in the context of Internet of Things. So that's why this question was actually asked in your paper. And this question, I think they would have taken it from the Hindu, because I remember that I had given a very similar question. I mean, almost a similar question, that I had given an entire text and I had asked what is it related to in one of the classes that I was taking before the prelims examination that year. And the exact same question came in the prelims paper. So either our sources were similar or they were also watching the lecture, one of the two. But whatever it was a lucky break that a direct question related to what I had given the in the classes, they, that question actually came in the paper. Anyway, so let's pause here. So there are few topics that are left in this chapter. One is about 5G. So we'll discuss about 5G, we'll discuss about blockchain technology, we'll discuss about supercomputers, and then we'll discuss about quantum technologies. So these are four topics that are left in this chapter. And then after that, the last chapter for us would be IPRs, or intellectual property rights. So these are the two things that are left for tomorrow's class. So any question if you have. Leaderboard. Okay, let me show the leaderboard. Yeah, so this is the leaderboard for today. Nice, two people, Satyapal and Ankush. You have all the questions correct. Wonderfully done. And many of you have just one wrong. That's fine. Hmm. System hacking is also a concern in IoT. System hacking, yeah, it is a concern. It actually would be a concern. That's true. How and in what ways working IoT is being used in reality? So today already we see that there are a lot of ways in which IoT based systems are working. We have seen that in traffic management systems already they are being deployed in a lot of ways, and in healthcare it is being employed. So for example, let's say especially in the intensive care units, the ICUs, where there would be a lot of checks for the vitals of a patient. So all these electronic devices that are checking the patient's vitals, they all will be connected so that they can keep giving the output every second to the doctor. They can pass on the information to the doctor every second. So we see that there are these instances where we already have started using IoT based systems. In many of the cases we see that in many of the cases we have seen that these IoT based systems are connected to the satellite, to the earth based devices, and in this way all these devices are connected together. Smart mirror. See, smart mirror is a concept that they have discussed here, where the mirror itself is able to show the weather indications and level of water, etc., in the overhead tanks. But smart mirrors already exist, but in very different ways. Can we use VLC in open space for long range? Still, we can't, because see, you'll have to have a very strong light source for that to happen. An LED light, let's say, if you're using an LED light, even then in wide open spaces also you cannot communicate for long ranges until the time the light has energy enough to travel. It would, because ultimately these are shorter waves, correct? These are shorter waves, it's not like radio waves. So that's why they cannot travel very long even in open spaces. No class of your one. Yeah, I know that even today I don't think class was supposed to be there, but because there were 2 Saturdays that were given to me and I did not take those Saturday classes, so that's why these are 2 classes that I'm taking today and tomorrow. Use of Li-Fi in defense. Yes, Li-Fi is being used in defense purposes also. Even in space technologies also, we have seen that they have started using the Mars mission, for example, of NASA. It uses Li-Fi. Dvaipayan, for the issue that you have regarding what you sent to Target IS the for evaluation, please send it to me. All right, please send it to me also. I'll just check with it, and I'll ask the team to get it done. Please explain again the point of digital surveillance of Internet of Things. So digital surveillance in Internet of Things basically is when we are saying that all the data from your devices are being collected. So for example, let's say even in these cases, so when you wake up, how many times do you tap the alarm, what is the number of alarm that has to ring so that you finally wake up. So each and every smallest bits of data about your daily life can be collected by these companies because they are connected to the internet. They can actually get all this information from your devices. Now we know that there have been even cases where how many times what is being typed, etc., that all can be uh, captured by the device itself, and the company can use it in whatever way they want. So that's why it is possible, and that is called as digital surveillance. मैं भी आ गया leaderboard में, unbelievable. So you, I hope that you get to the leaderboards every day, and at least learning is important. If not, even if you don't get it correctly in these sessions, it's fine. Does Samsung 5G handsets have Wi-Fi 6 or not? Some of the devices have, not everyone. More than Internet of Things, it's looking like my home is made up of advanced general AI. uh, it's still not general AI because everything is trained, and it's only doing what it has been trained. In chess, there are two AI, Stockfish and AlphaZero. AlphaZero is more efficient than Stockfish because it can think of its own. It has been trained with a lot of data, and a lot of uh, ways and moves and probabilities have been used there. That's why it has become way more advanced. Does UPSC repeat questions? Sometimes it does, but most of the times it will not. If not, then why should we study those topics in which questions have been asked? Because it's not that if the question has been asked, they'll ask the same question. They would repeat the topic, they would not repeat the question. We just discussed Li-Fi, right? We discussed Li-Fi, and in Li-Fi, there are two questions that they have asked. This question was asked in 2016. This question was asked in 2022. Sorry, 2020. So within 4 years, they repeated the question from the same topic. So you cannot shrug off the topic if they have already asked the question. Depends on whether the topic is relevant or not. If the topic is no more relevant, then it's fine. Then they'll not ask you the question from there. But the topic being relevant, they can ask a question from the same topic. They cannot bring in new topics. The chapters are the same. So they will have to ask the questions from the same chapters. Just that the questions would change. They'll find newer ways to ask questions. Hmm, so these are repeated questions. When writing in ChatGPT that give a village picture with sunset, it says it can't do it. Depends on whether you are using the extensions correctly or not. There are plugins for it to generate images. The normal, the free version of it cannot do it. The paid version actually can. Notice many of the times that whatever I have discussed with my family and friends, devices show the same information because the devices are listening. The devices are listening all the time. So it has happened with me. I was taking a class in Chennai, and so I might have uttered the word solar energy a lot of times while taking the class. It was a weekend class in Chennai, and 2 days later on a Tuesday, I get a call, and in that call there is a lady on the other side, and she asks, "Sir, are you looking for a new connection of solar energy at your home?" So forget about you getting advertisements on your social media posts, etc., or the social media handles. I got a legit call uh, asking whether I wanted solar energy connection. I never asked for any solar energy connection whatsoever. The only thing that I did was that I took a class where I would have said solar energy n number of times, or maybe I would have just searched solar energy news, that if there is something new that I need to tell to the students in the class. That's the most that I would have done, and I get a call that, are you looking for solar energy connections? Yeah, it happens. In prelims, I'm asking from the complete paper aspect, which part is more important, static or dynamic, only from prelims, including all subjects. See, uh, it's always have been a mix. So if you look at different years, you'll find different patterns. Look at 2016 to 2020 to 23 papers, you'll see that every year the thing is different. 2016 or 2017 paper rather, it had more than 65 questions from current affairs. 65 current affairs question. The very next year, only 20 questions from current affairs. You can't predict. You can't really say that they'll ask only dynamic questions or only static questions. All of a sudden everybody just started reading current affairs. They did not ask current affairs next year. So every year the things change, and that's why we cannot predict that these many number of questions will come. For good 3 4 years, they hardly asked 5 6 questions from geography. A subject, a big subject like geography, they just asked 5 6 questions. Who can say that that would happen? But then they started asking 12 13 questions again. One year they asked just 7 8 questions from polity. Everyone was shocked because everyone just reads polity and modern history and goes to the examination hall. The next year they asked 22 questions from polity. They made up for the less number of questions. So that's why you really can't do anything. I mean, you'll have to prepare for the syllabus without thinking of that can be asked or this should be asked. Yes, of course, every year there will be some topics which will be very very important, but there will be a lot other questions also. From the very very important questions, one or two questions will come. Rest will come from other areas. So that's why you always say that forget about whatever has been asked and what the pattern has been. Always prepare for the syllabus and everything that is there in front of you. That's the only way to prepare and qualify this examination. If it is, if we receive sending via Bluetooth damage, would it damage my mobile? No, it would not. Why would it? $20 a month for paid version with Dali AI. That's true. I mean, for all the extensions that you need with GPT-4, they charge $20 a month. VLC media player is different. Oh yes, of course it is very very different. VLC there is very different. I think video LAN player something. This is what the VLC player full form is. Way of explaining interacting is amazing. Thank you for the compliment. Done. That's it. So let's meet tomorrow. Tomorrow is our last class tomorrow together, and we'll complete this chapter and we'll move on to the last chapter of intellectual property rights. Right. So let's meet tomorrow, same time, 5 p.m. in the evening. Thank you.